here today for the last time. Okay, this is 7th week and we are going to complete 49 hours. Okay, 49 hours. This course has only 48 hours, but we are doing an extra 1 hour. So every week when we meet, we do 7 hours like that. Excuse me. So by the end of today, we would have covered 49 hours. Okay, that means no more lecture for you on AQRM, no more Tuesdays lah with me. You are free now after this. Like I think Max and Michael's group all, I think they can continue with your research already. Your proposal, your research writing, no more courses for you. I mean, no formal courses lah. If there is a seminar, we will let you know and just join us. Otherwise, there is no specific formal courses. Okay, but for the new students who have just entered this semester, you may be doing a research proposal. You may be doing my quantitative research methods. It's not finished. There's one more research, qualitative research methods, which will come next. Okay, after finishing this, will come probably next semester. I'm not sure, because if you are a special intake group, you only will be with us for 7 or 8 weeks. After that, you go back to work. Then you come and join us again in January, I think. Okay, after this, I think the next lessons will be starting in January for you. If you are the special intake group, only the conventional group, they come more times, and they will be with us for about 3 months, 3 months. So their structure is very different. Content is same, but then the delivery is quite different, because we do not meet them for 7 hours. We only meet them 4 hours. So we will redistribute the content according to the schedule, 4 weeks, 4 hours per week, and that will go to about 11 or 12 weeks. Same also, 12 times 4 is 48, but you are doing 7 times 7, 49. Okay, so the same content, same level of lectures and all that, same quality. The only thing is that the time is shorter. Okay, so you need to be more hardworking if you are in a special intake group, because you get the lectures more, and the time between one lecture and another is short. You see, 7 hours, whatever we did, you must go through, must practice, and then before you are able to use the skills, use the applications, there comes the next one, you see. So maybe it's a bit tight for you compared to the conventional group, who will be doing only 4 hours per week. So for them, it is much more a decent form of delivery. Okay, because as an educator for many, many years, I've been in the education field more than 35 years. I know that learning doesn't come like that. I can't give you everything today. Okay, let's say that I start 8 o'clock in the morning. I give everything that I have here to you until the whole course is done. That is no use, because what you will take in is very little. So it's a waste of energy from my side and your side. So the best thing is you spread it out so that the learning is very gradual, little by little, but effective. Okay, so that's why I was comparing between the special intake and the conventional. Conventional, they only stay there for 4 hours, then they practice. The next time they come, another 4 hours, whereas once you come, 7 hours, another time 7 hours. So a lot to take in. Okay, so it's okay, but you chose to be in the special intake and they chose to be in the conventional. Okay, I have about 40 plus, so I'm getting started now, and I'm recording this session, today's session. So in case you think that never mind, I think I just posted it to the Blackboard, so everybody can access to it. Everybody can see that whatever we are talking, whatever I'm teaching for the whole day today, I will be recording and I'll post it in the BB, so you can listen to that. So even if you miss something from me, you can still listen to my audio. Okay, audio recording is on. Huh? Okay, let me go to my lectures. Okay, can you see my slide? Class, can you see my slide? My PowerPoint?
Yes.
Yes.
There is an echo, you know. Echo means my own voice is coming back to me. Okay, someone's for, I think, phone or what. Okay, let me get started. Today, as I told you a bit some time ago, that today is our last lecture, lecture number 7. And with this, we are completing the whole advanced quantitative AQRM, advanced quantitative research method by me. And then I wish to run through what we did all this while, starting from lecture 1. I just mentioned the topics and see that if you have gathered the input that I gave you. If not, you may have to go back and read up the PowerPoint and then make sure that you have learned all that. Okay?
Yeah.
So what we learned in lecture 1. Okay? This is what we learned in lecture 1. What are variables, what are the constructs, and something about quantitative study and its relationship with the measurement. In quantitative, we use numbers, so the numbers must come with the measurement. Okay, everything that you are studying, like anxiety, learning, achievement, English skills, whatever you are studying, all must be converted to numbers measurement. Okay, that was the basic for quantitative. What about my voice? Is it clear, class? Is it clear?
Which one?
My voice. Is
Yes.
it clear?
Yes.
Okay.
Quite
If not,
clear.
okay. If it's already maximum, huh? I put it at maximum. Okay. This is what we did in lecture 1. Just recall. Okay. Then in lecture 2, what we did was several research methods. Because I didn't start immediately into the data analysis. I started with the theoretical part of the research methods. Okay, what are research? What is research? What are the methods available to us? Because you are a researcher now. See, now you are in a researcher phase. The moment you join SEGIF, either in a special intake group or the conventional group, you already decided to do some research at that level, PhD level. So you need to know the theoretical background of what is research and several methods that are available to you. So which one you want to use in your study, whether you want to do an experimental or quasi-experimental or non-experimental, just hold it. Eh? Okay, back to where I stopped. In lecture 2, we were doing the theoretical part of the research methods. I was talking about research methods and then the several designs that are available to us. For example, experimental, quasi-experimental, the difference between experimental, quasi, and what is a non-experimental, and within the non-experimental, are you doing a correlational study or are you doing a survey, descriptive study, whatever, all this we discussed. And finally, we said the trend now is not purely quanti or purely quali. It's now a mixed kind of design, mixed methods design. And there are several types of mixed method, which one you want to do, all that we discussed. In lecture 3, what we did was We continued with experimental and quasi. After that, I gave you some examples of quantitative studies, how do you get started and how do you move along the study, and what are the measurements you do after getting the measurement, or before getting the measurement. What you do, you go with the instrument, you collect the data, and then you analyze the data. Okay, all this we discussed. And in the lecture 4, we entered into SPSS, introduction to SPSS, followed by data entry and data cleaning. Okay, how to enter data into the SPSS platform, and then how to make sure that the data is all very clean. Clean means no missing values, no outliers, no unusual numbers, no reverse coding still existing there. Okay, so make sure all these are clear. So once all these are clear, we call it a cleaned data, because a clean data will help you get more accurate results when you do analysis. Otherwise, your results won't be accurate. So your conclusions will also be not accurate. You see, it's like a chain reaction. The data is not clean. When you use it for analysis, your analysis is not complete, not accurate. Therefore, your decision and conclusions all are not accurate. So data cleaning is very, very important aspect in a research, especially quantitative research. Okay, then I also taught you what we mean by descriptive analysis, descriptive statistics, which uses mean, median, mode, range, standard deviation, standard error, variance, maximum, minimum, and then whatever we measure, and then we use it quite directly. That means you don't go through a test. Okay, that is called descriptive statistics. Okay, and the parameters that we use for descriptive will be the mean, median, mode, variance, standard deviation, standard error, maximum, minimum, range. All this comes under descriptive. And in lecture 5, we still continued data cleaning to ensure the reverse coding all touched and completed. Then I showed you how to test for normality. This is an important aspect. Actually, some years back, about 10 or 20 years back, the test for normality was so essential, so important. Because if your measurement, let's say creativity, or let's say anxiety, you collect data, and that data distribution, that means you put the data in a graph, the distribution of the graph, if it is not normal curve, if it doesn't follow a bell-shaped curve, then we say it is not normal. But if it follows a bell-shaped normal curve, where the mean is at the center and symmetrical on either side, left and right, then we say it is a normal curve. If it is normal, only then, when it is normal, only then your data qualifies for t-test, ANOVA, multiple regression, and all other very, very robust means strong and powerful tests. If your data is not normal, that means it's skewed, it's not symmetrical, it's skewed or catoic, then your data does not qualify for t-test, ANOVA, multiple regression. And you have to go into what we call non-parametric tests. Instead of a t-test, you will be doing a Mann-Whitney test. Instead of an ANOVA, you will be doing a Kruskal-Wallis test. Instead of the normal Pearson correlation technique, you will be using a Spearman-Rowe technique. See, all the techniques will be different, because you cannot simply use the t-test and ANOVA without any consideration on the data distribution. You know why? Because you are doing a research at the highest level, PhD level, or maybe master's level. And if you do not adhere means ADHERE, adhere, follow. If you do not follow strictly to the theoretical aspects of statistics, the statisticians will not agree with you. They will say and tell you, you are wrong. Methodologically, your analysis is wrong. Therefore, whatever you wanted to say, they don't listen to you. They say you are wrong. So in terms of methodology, you must be correct. So make sure your data is normal and your measurement is interval or ratio. See, all this I keep on saying many, many times, because even when I was beginning to be a researcher, maybe about 30 years back, or maybe let's say not 30 years, about 20 years back, 25 years back, I also didn't, realize that measurement must be interval, ratio. I thought any measurement can be applied, but it's not true. It is not true, because according to the real mathematicians, if they are very strict, they won't allow you to do a t-test if they find that your data is not normal. If they find your measurement is not interval, they won't allow you. They will say you are wrong. If the method is wrong, your research is wrong. Okay, other places you can adjust, but if you did something methodologically which is wrong, then you are wrong. Okay, so you have to be very careful when choosing your analysis techniques. You want to do t-test? Test for normality. Test it. Make sure it is normal distribution. Then you go and do your t-test and ANOVA. Test for normality, then only you move to the other robust. Robust means strong, powerful techniques. Okay, analysis is there. Either you want to go to the tough, powerful one, or you want to go to the weaker one. Non-parametric tests are weaker ones, weaker compared to parametric tests. So people always want to do the powerful test, so that they say my claim is very good because my finding is so good. I use t-test, I use ANOVA, my finding is so good. Yeah, that's the nature of the researcher. They always want to say big about their research finding. But remember, your path, your journey must have gone through the proper stations, meaning that your data must be interval or ratio, your distribution must be normal, and then your choice of the test, whether it's a t-test or ANOVA, the choice must be correct, the application must be correct, then the interpretation must be correct, and then your conclusion must be correct. So there is a long procedure there, and you have to follow that exactly. You must understand and then follow it exactly. Okay, so that's why we have to do a test for normality. Even when you finish your data collection, you have to send the data for the testing of normality. Okay, after the normality testing is done, you are sure that the data is normally distributed, it was collected at a scale of interval or ratio, then you qualify for the t-test, and then we also learned how to do a t-test. Remember, a t-test will test. A t-test, the word test is there. A t-test will test whether two groups show significant difference in their scores. Let's say you measure anxiety for examination. You go and measure in one class, boys and girls. The boys' mean score for anxiety, the girls' mean score for anxiety. So you have two numbers, two scores. You want to say whether the boys' score is higher or different than the girls' score. If you are interested in finding out whether the difference is significant or not, whether it is really true or not, is it true that the boys' score is different from girls' score? And then you have to do a t-test. Okay. If you are doing in a school where there are many classes, class A, B, C, D, E, maybe until E class. So all are same standard. All are same form. In Malaysia, we call it form, let's say form 4. Form 4 means 10th grade. Okay, grade 10. Grade or year 10 is called form 4. Let's say I have in my school got 5 classes. 5 classes of grade 10 students. Class A, class B, class C, class D, class E. 5 classes. Now I'm interested in finding out whether class A score for anxiety It's different from class B, different from C, different from D. That means when I'm comparing the difference between and among many groups, more than 2 groups. Just now 2 groups only, I use a t-test. But when I do it among many groups, more than 2, maybe 2, 3 groups, maybe 4 groups, 5 groups, 10 groups, 20 groups, then I cannot use t-test. Not to say cannot, t-test can still be used, but it becomes very tedious because t-test only take 2 groups at one time, 2 groups one time, 2 groups. So if you have 5 groups, how many times you have to take? You have to take many, many times. So that's why we don't encourage them to do t-test. We say, okay, go straight to the ANOVA, analysis of variance, ANOVA, one-way ANOVA. There you can find the group, whether different or not, and which group is different. All this we have done. All this we have done. I'm just going through it because this is the last class for the course. Then in lecture 6, I started with ANOVA. That's what I was telling you just now. Then I also taught you about correlation. Correlation, we use Pearson moment correlation matrix. Okay, I told you how to use a matrix. Every number that you see has got 3 features: the positive, negative sign, one information; the number, one information; and up there, if there's an asterisk mark, star mark, another information. So every time you look at the number in the correlation matrix, it carries 3 information. One for the sign, positive, negative; another for the number, 0.736, 0.3, whatever. Then the asterisk mark on top to show the significance, whether the relationship is significant or not in the population. The moment we say significant, that means we are not talking about the sample, we are talking about the population. But we are using a sample, but we want to generalize to the population. That's why the word significant always come and join. See? Okay. Then I also introduced to you factor analysis, in particular EFA, exploratory factor analysis. Why it is exploratory? Because you are now exploring. You do not know what are the factors. You have a construct and you have some questionnaire items, but you do not know whether these items all measure the construct or not, all measure the variable or not. So you have to go through a factor analysis, and this is an exploration. That means it's a beginning phase. You do not know, so you're trying it out. You try out. You put all the 10, see how it goes, then you adjust, you come back, you put another 5, some you remove, some you add in. This is called exploration phase. That's why it's termed exploratory factor analysis. There is one more phase called confirmatory. Confirm that the factors are true. That means you're testing, you're validating. But down here in the EFA, you are not testing, you are not validating, you are just exploring whether the items can measure. Okay, that's what we did last week. And I will continue with that a bit more. And then for today, okay, let's see what is that we did. Okay, this is what we did last week. And for today, what is waiting for you is all this. Okay, all this are waiting for you. The EFA I will touch, and following the EFA, I will teach you how to do a reliability test or reliability check. Either you call it reliability check or reliability test. Then I will move into the regression family, the family of regression: linear regression, standard multiple regression, stepwise multiple regression, hierarchical multiple regression. So I will go through each with an example. And then I also intend to show you a recent study by one of my students. She will be using all quantitative. I will show you the study, the conceptual map. I will show you her research questions, and I will show you what are the analysis, what are the data analysis, what are the tests that she is using in the analysis. Which test? Is she using a Pearson moment correlation? Is she using a t-test? Is she using a stepwise? Something like that. I will show you. So by the end of today, you are supposed to have learned from me, plus your own learning, everything that you need to finish up your research in terms of analysis, methods plus analysis. I talked about a lot about methods, so that one also you should know, and then the measurement, and then the data entered into SPSS, and the kind of analysis that you are supposed to perform to answer your research questions. I will show you all that. I will show you examples. Okay, let us begin. Just before I begin, anything that you want me to answer you? Anything, any question from you, class?
Hi, doctor.
Yes.
Hi, I have two questions.
Okay, your voice is not clear, huh? Not very clear.
Sorry.
Are you using a mobile? No.
No, I'm using computer. Is it okay now?
You are Michael, is it?
No. Sorry. My name is Li Shuqing. Yeah.
Okay, carry on, Liu.
Okay. Yeah. Sorry. The first one is just now I saw you. You were saying not experimental, and you mentioned the survey. What is the difference between survey and questionnaire?
Oh, survey is a method. Survey is a method like experimental method, non-experimental method. Survey is a non-experimental method. Questionnaire is an instrument to measure, to collect data within the survey.
Okay.
Okay, it's inside the survey. It's a questionnaire. It's an instrument. It comes under instrument. Survey comes under method.
Okay, understand. Okay. Is it?
But anyway, your voice, Liu, your voice is very difficult to follow because there are some background music, you know, at the back.
Oh, okay. Sorry. Maybe I use. Sorry.
Okay, never mind. Any other question, class? Any other questions?
Hello. Hello.
Yeah.
Hello, sir. Yeah, can you hear me now?
Okay. I don't know why your voices all goes into what shall I say?
Is it?
It's a bit noisy, you know. Your the way you speak. It's noisy. I don't know. Okay, never mind. You speak and see. I'll try to catch what you are trying to say.
Sorry. The number two is I understand that you can see construct is not a variable.
Very sorry, I cannot get your question because your voice is not clear.
Oh, yeah. Sorry. Let me try to log in.
Maybe you can type at the chat session over here. You type whatever you want at the chat. I try to read and see. Okay, Kenna, can you do that?
Yes.
Okay,
Professor?
on the chat. Yeah.
Actually, we're not sure about the deadline for the assignment one because
The first assignment that I gave you this Friday is the deadline. This Friday. I put a date also. I thought I gave you a date, due date 28, I think.
28.
This
28.
Friday. This Friday is
The assigned one is must to submit is the 28th
yes.
August.
This
Okay,
Friday.
thank you.
Okay.
Thank you.
You have one more assignment. Assignment 2 is coming tomorrow. That is for next week. The due date is next week.
So assignment 2 is the deadline for the assignment 2 is next Friday?
Next week. Yep, next Friday. Assignment 1 this Friday, 28. Assignment 2 will be 4th of September.
Oh, thank you. Thank you.
I give you about 1 week. It's not very tough. Just exactly what we are doing here. It's more for your application. You just show me how well you have learned the skills. Is it? Okay, any other questions?
Hi, sir. Sorry. Can you hear me now?
Yeah, try and see. We will try. Okay.
Sorry. Yeah. I just want to check, I heard you keep on saying construct is not
Yes.
a variable. However, how come, if construct is not a variable, how come we call it a dependent variable?
I never said it's not a variable. It is a variable.
Oh, okay.
It
Sorry.
is a latent variable, meaning that it's a hidden variable. You can't see it. You can't measure directly. For example, your intelligence. Intelligence exists or not? Yes, it exists. You are an intelligent person, isn't it? So the existence of intelligence within you is there, but I cannot see and measure. There's no way to measure. Okay? If it cannot
Okay.
be observed, all constructs are variables. Some are very visible variables. We have direct measurement, like a table, the height of the table, the length of the table, the width of the table, all direct measurement. So we don't call them construct. If a construct like learning, how much you have learned, I don't know. I cannot see and measure. It's not observable. So I call it a construct.
Okay, got
So
it.
anxiety is a construct. Okay, achievement, sometimes achievement is also a construct. Some people say, oh, achievement, maths achievement, I look at the score, I know. And that is not a construct, if that is your definition. But if you say, oh, my achievement means everything that he has achieved, is a very composite one, then we call it construct. It's just that we cannot see, we cannot measure directly. That's why we need items, we need questionnaire. And inside the questionnaire, we have a lot of small questions to support us to identify the measurement of the construct. Okay?
I understand. And sorry, sir, another one is the normality.
Yes.
I understand the precondition for normality. I understand the precondition for t-test is this distribution should be normal.
Yes.
And if we go back to see this UG and PG, we can see, from box plot to QQ plots, and it shows this is normal. However, remember last class when we were doing the Shapiro Wilk test,
yes.
the result was 0.00, which means it was significant. So
yes.
if it's significant, how can we proceed to do the t-test?
You cannot actually by right. When the Shapiro-Wilks test doesn't show a significance, then our conclusion is it is normal. But if it shows some significance, then the data is not normal. But sometimes when you look at the box plot or when you look at the histogram, you will get approximately normal, not really normal. You see all measurements that we collect cannot be ideally normal, cannot be strictly normal. They will be moving slightly that side, this side, but they won't be skewed. That means that won't slant. They won't be slanting this side, that side. They will show some sort of normality. So the condition for normality is approximately normal. That's the word, approximately.
I understand. Okay, but it's very confusing, and also it's not
very good. Your question is good. Your question is very good, because if the Shapiro-Wilks test, you see here, when we test for normality, we have two methods. One is graphical method, visual method. Another is a statistical method. The visual is box plot, the histogram. All these are visuals. The QQ plot. QQ plot. You remember QQ plot? A straight line with a lot of dots hugging the line. That's a QQ plot. And then the box plot, there's a box with whiskers and all that. These are the graphical assistants for determining the normality. If you don't want that, you can go to the statistical. Statistical comes with the skewness, the kurtosis, the values, and then the Shapiro-Wilks test. These are the statistical way of confirming whether it's normal or not. So you do both and see. But the idea behind this normality is you don't look for real normality. You can't find ideal normality. You cannot find an exact symmetrical bell-shaped curve. That's not possible. So the word is approximately normal. If it's obviously skewed, then definitely it's not normal. But if it is shifted from the center but slightly to the left, it's still okay. It's still, that's why the box plot may be a better idea. If the box plot, the center line is too much lower or too much high, then it's not normal, you know. It's somewhere in between, somewhere near the center, then it's approximately normal. And you check the
Okay.
whiskers, the length of the whiskers. I mean, that's what I say. There are two methods. One is graphical, another is statistical. So you can test both and check. Okay.
Sir, can I understand it in this way? You know, in our research, if the findings for visual and numerical are different, can we just you know, put one in our research and leave the other one out?
No, no, no. Please don't, because at your level, PhD level, it's better you confirm with more evidences. You see, yeah,
In
you are
that case,
trying
it's
to.
not convincing. Someone will question us by saying, you know, how can you use a t-test since, you know, the significance is very big.
What do you mean? What's your question?
No, my question is, if we keep all the visual and numerical tests into it, then people may question, you know, how can you do t-test since, you know, the Shapiro shows it's significant. Although, you know, the box plot shows it's approximately symmetric, but anyhow, you know, this Shapiro shows is significant. How can you still, you know, proceed?
No, by right you cannot proceed, because if the Shapiro is a better value than the others, because the others all are visually approximately, but that is a more statistical one. Okay.
Okay.
So if Shapiro strictly says not significant, then it is a normal. If it says significant, then it's not normal. You can have a look. Actually, you can also take that particular distribution and plot it and see. That's what we see. A box plot all exactly from the data, I know. Exactly. The box plot is an exact version of the data distribution. So you can see from there, you draw the normal curve, normality curve from the data and see how well it behaves. If it behaves almost normal, then you can take it, you know, you can take it. Because visually also it's showing you I'm normal. See, I am normal or approximately normal. So we can use it. These conditions are sometimes there's an adjustment line, some negotiations. If they're totally very much opposite to each other, meaning that graphical shows it's approximately normal, statistical doesn't show, seldom occur. But that's where your confirmation must come in. Your knowledge should come in, whether to accept it or not. Okay.
I see. Okay.
We cannot be very strict, but we always do the procedure. We use the procedure until we can go into the t-test. Because if the graph, if the distribution is normal, the only thing is that I cannot do a t-test, but I can do the non-parametric test equivalent to t, which is Man-Whitney test, which will also tell me whether the difference is significant or not. I'm not stubborn. I'm not stubborn to use t-test. If the structure of my distribution, the curve is not normal, Shapiro works says significant, meaning to say it's not normal, then I leave the t-test. I don't go into the parametric t-test. I go into the non-parametric Man-Whitney test. Yeah, I have a choice. I have a choice. See? Okay. Very good question. Very good question.
Yes, sir.
Okay.
Yeah. Yeah, I have the last question.
Don't say last. You can ask many more.
Thank you, sir. Yeah,
There are
I
many
just
more.
don't want to take too much time. Yeah.
Okay, come.
Yeah. Sorry. I understand why we are doing this CFA for, you know, like those
EFA.
Oh, sorry, EFA. Sorry, this EFA for pedagogy, etc. But I don't understand why we are doing the, you know, the checking for the relationship between pedagogy and the other dimensions like personality.
No. Can I know your name? Are you Liu? Liu something, is it?
Sorry, my name is Li Shujing, Li.
Okay,
It's my surname.
Li. I call you Li lah. Okay.
Please, yeah, thank you.
Okay, Li. It's not for relationship. EFA is not for relationship between variables. Li, the EFA is to check whether the items that you are using in your questionnaire, are they measuring the construct or not? You see, let's say pedagogy. Pedagogy for me is a construct. And then I'm using, say, 10 items to measure my pedagogy. What I'm doing now in the EFA is, are these 10 items, are they really measuring the pedagogy or not? Is it possible that some of them are not functioning? That process is EFA.
I understand, sir. Maybe I should readjust my question. My question is regarding to that one graph. Remember, we have one graph which we list all the other dimensions on the left, and on the right we put pedagogy, and we put errors towarding to pedagogy.
Okay, good.
Yeah.
Good. No, that one
有
we
一个
don't
人
use.
在问问题，问了好几久。
No, for that we don't use EFA. EFA is between the variables and the items. It doesn't go into the variables. You see, what you are saying is the inner model. What we are doing in the EFA is outer model. Okay, don't worry. Leah, don't worry.
Yes,
After
there
this,
are many new things.
I'm coming in. Juliet,
After the class, you can ask the professor the questions.
Juliet.
Yes, there are many things. Is the last week's questions.
Don't worry, I will give you today last half an hour. I will give you time for questions also. Don't worry. Let him ask, because sometimes his questions is not only for him, for the rest also. The others also will enjoy, will benefit. I'm sure his questions are very good. All his questions are good. See. Okay, don't worry. I'm going again. I'm going again to the EFA today. I'll start with EFA, and then I'll show you where the EFA comes in. It's not on the right side, it's on the left side. Okay?
Okay, sure. Thank you, sir.
It's not inner model, it's the outer model. Okay, let me begin, continue. Okay, these are the things that I'm going to do. But before that, you see, just like what I told you earlier, if you want to do parametric tests, which includes t-test and NOVA and all this, similarly, if you want to do multiple regression, you have to follow some assumptions. You have to follow some assumptions, okay? Let me go through the assumptions for multiple regression, or maybe I reserve this, I go to the EFA first, because I think I'm not finished with EFA yet. So we leave this a bit, and then let me show you something on EFA. Okay, I'll show you some statistics based on EFA. Just give me some time to open up my SPSS. It takes a while to open the SPSS. Can you see my screen?
No,
Are you cannot see my screen? Cannot see. Okay, now can you see my screen?
Yes.
Okay, now only opening. You see, you can see now only it's opening the SPSS. Let it open. I open one. What do you call one data for you? Okay. I'm going to open a data. Let me see which one I want to open. Lecture 7. Okay, maybe I go for. Okay, can you see my data?
Yes.
Okay, class, this is actually the UG/PG, the undergraduate, postgraduate teacher competence. Okay, what I'm going to show you is that you can see in the data here, D11, D12, okay? Let me show you all this. D12, 13, 14 until D112. Okay, what are these items? These are items, these are the questions in the questionnaire.
Yes.
And all these 12 items, they were measuring for personality. Personality is a construct. I cannot measure it directly. So what I do, I use small questions inside my questionnaire. I can call them items, I can call them questionnaire, but to me, a question, a question means must end with a question mark. So if it is a statement, it's proper to say it's an item. So let's say I call them items. So I have 12 items to measure my personality. But these are actually items constructed by me, by myself, you know. Of course, now I refer to the literature, I read some articles, and then I try to formulate the small items. How sure I am that all the 12 are measuring the personality? I don't know. I must test it out. Normally people say, okay, you go for reliability test. Yeah, reliability test can tell you which one is useless, which one is useful. But reliability cannot tell me within the 12 whether got more than one component or not. Whether the 12 go into one, or whether the 12 split, go into two, and then from the two go into one. The one reliability check cannot tell. Reliability check can only tell me whether the 12 items are measuring or not. Whether this 12, from 12, it is reduced to just 2, 3, it won't tell. I have to do a factor analysis. That's what I call it EFA, because I'm exploring. There's no theory behind me in the literature to tell me that, oh, these 12 are measuring. There's no validated information. So I am testing it, I'm trying it out, I'm exploring. That's why I use the word exploratory factor analysis. So I'm going to try now. Let's see whether the 12 go into one factor, which we can call personality, or is it going into more than one factor, and from there it merges into personality. I don't know, I'm going to check. So I go for analyzing, I go for dimension reduction. You see, the word dimension reduction means from the 12, it's going to reduce to some 2 factors or 3 factors, whatever. This part is called EFA. See, I haven't come to the relationship on the other side. Thus, personality may be related to pedagogy, the one I'm not talking about now. I'm only going into the construct, which is called personality, and the items that are measuring the construct personality. Just one personality with 12 items. I'm measuring this side. That's why I say this is called outer model. Okay. Okay, let me go to the reduction, then go and pick factor. Okay, now what I do, I'll send all the 12 into the window. 10, 11, 12. Okay, I send all of them inside. And then I select my test. This factor analysis, you see, initial, yes. You can just select all this: coefficient, significance, determinant, and KMO. KMO is important. Definitely don't leave KMO. If I don't do the others also, not so bad, but the KMOs must be done. Then go to the extraction. This is what we are doing. We try to extract. We are trying to extract from the 12 items how many smaller components can I get. Whether the 12 will make 2 or make 3, make 4, 5, 6, okay, how many it can give me. So I go and tell SPSS, you do the job. I'm not fixing the number of factors. SPSS is going to tell me how many factors. So this is the option, based on the eigenvalue, more than one. So it will arrange the factors. The moment the eigenvalue calculated and it is more than one, it will create one factor. Another one, create one factor, like that. So it's going to do for me, okay? Then on the rotation, you see here, the 12 items, no doubt I am the one who said, I'm not very sure whether they are related or not among themselves. For example, D11, is it related to D12? Is D12 related to 3? I'm not sure. But they must be related, for your information, they must be related. Okay, not so strongly. There must be a relation, but the relation cannot be very strong. Okay. You may ask why, why related but not strong? Because if they are so strong related, then only one it will do. You don't need two. Okay. It's like two of your friends, they are equally good, almost equally good. Then one friend is enough for you. The other one is like a redundancy, see? Something like that. So the personality looks at D11 and D12 as equivalent. They have equal strength, and so they just take one is enough. The other one, no need. Redundant, we call it redundant. So you don't have to bring in more items when they are almost the same. Okay, so I go in here, then I go for the rotation. Now I do not know whether they are related or not. So I'm going to try first whether they are related. If they are related, I do the bottom two, either Promax rotation or direct oblique. Oblique means like oblique, means slanting, they are related. If they are not related, then they are called orthogonal. So they can be Verimax, they can be Quantamax or Aquamax. Any of the three will do. Usually people go for Verimax if the items are uncorrelated. If the items are correlated, then we go for either one of the down one, Promax or Oblique. But usually, according to studies, that Oblique is the better choice for them. You see, all these are possible techniques. You can do Promax, you will get similar answer. You do Oblique, you get similar answer. But most researchers, according to studies, many studies, they said many researchers use Oblique instead of Promax. Many researchers use Verimax instead of the other two, Quantamax and Aquamax. But you have to decide between the two. Correlated, one group, uncorrelated, another group. So now I'm investigating whether they are correlated or not. Okay, so rotation done, scores, nothing, don't do anything, scores. Then options, okay, go to the last two, sorted by set, and this one also. This one you put 0.3, 0.3. Okay, 0.3. Then I say, okay, you see, it's going to do. See, this is the correlation matrix table. That means all the 12 will be correlated with all the 12 again. So you can see D1 related to D1 is exactly perfect. D1 related to D2, okay, is 614. 0.614 is moderate, is a moderate relationship. D1 related to D3 is 0.3, not moderate, is on the weaker side already. 0.5176, 0.4 moderate, 139 very weak, 177 also weak, 108. You see, the items are there, but they're not strongly correlated with the other items which are around. That means the neighbors. D1 doesn't have to be strongly with all that. What we want is, we want a moderate relationship. We don't want a weak relationship, neither we want a strong relationship, because strong means will disturb us, weak means it won't be very good. Okay, so we want a moderate relation. That means something more than 0.3. Okay, 0.3 or around 0.3 and above, less than 0.7. So we don't want more than 0.7, we don't want less than 0.7. But what happened is already here, we are going to change it. So we don't do anything here, we just observe, okay, then you have some idea in your mind that some are very strong, some are not strong. It's okay, it's okay. Just go to the next table down, KMO table. KMO, you have to look at this number. This number is telling you whether the sample that we use, the sampling, was adequate or not, whether it's adequate. I have 90 cases here. Okay, I have 90 cases, so it must be sufficient. That's why it's giving me a figure more than 0.5. We accept more than 0.5. If it is 0.6, better. 0.7, better, even better. 0.8 is good, something like that. The higher, the better. Okay, then you look at the down one, 0, 0. 0, 0 here implies that some of the correlations here are significant, or there is a correlation. If there is no correlation here among the items here, no correlation, then you don't get significance here. Automatically, you cannot proceed. You can't continue with the EFA. See, just like what our friend asked me, Lee, the test for normality fails, what do we do next? Actually, we cannot do t-test, but we have an option the other side. Here, we don't have an option. If it's not significant, 0, 0, 0, stop it. No more EFA, because your sampling is not enough. What you should do, you go back, collect more sample, come back and try. Okay, that's the message lah. So now we are safe because it's telling me that it is enough. So I can continue, significant, correct, then go to the commonalities, then go to this variance. This is where you get the number of factors. You see on the right, you're getting one factor, two factors. And look at this cumulative part, this part. Can you all see my cursor, class? Can you all see my cursor?
Yeah, yeah.
Okay, so look at the first cursor, 48.715. That means 48.7% of the 12 items, 48.7% of the item, they are going to first factor. Okay, another 20, but not 20, another 15. 48 plus 15 is 63. Because this is cumulative, means every time another factor comes in, it collects cumulative. That means it adds to it. So by separately, if I separate them, one is 48. The first one is very strong, 48. The second one is about 15%. So first factor uses about 48% of the changes in the 12 variables. The second factor takes in about 15%. So the total is 63%. As long as the total here is more than 50, then you can proceed. You can go on. You can go on. You can use the two factor. Okay, so now I know that I have two factors. Okay, so this is the first message I pick up. I have two factors here. Then I go down here. Don't have to look at all this. Go down to the last one. This component correlation. Look at this correlation between the two factors. Now I have two factors. Are they correlated or not? Are they related or not? So I'm looking at this number. 0.43 is a moderate correlation, you know, it's a moderate correlation. Because between 0.3 to 0.6 is moderate. More than 0.6 is good, very good, strong like that. So below 0.3 means, so this comes under moderate correlation. Some researchers, they are very strict. They say as long as the number goes above 0.3, it is correlated. Less than 0.32, especially 32, their figure is 32. As less than 0.32, they are not correlated. So I told you, when you do this first portion of the EFA, we are looking to check whether the 12 items are correlated, not the 12 items, but the two factors that emerge, the two factors that come out of the process, are they correlated or not? If they are related, then you have a different technique of rotation. If they are not related, then you have another technique. So in order to specify the technique, determine the technique, you need to check whether they are correlated or uncorrelated. And you look at this number, 0.430. 0.430 is on the scale of reliability, on the scale of correlation. It is considered moderate. And I told you, some researchers, they are very strict. They say if the value is above 0.32, they call it related, correlated. If the value is less than 0.32, they say uncorrelated. So if I take this as correlated, they are correlated, then I go back to the test. Go back to the test. Okay, where was the test? Just now, rotation technique. So I know they are correlated. So I stay put with the oblimin. I don't change anything because oblimin is for correlated and oblimin is a better choice compared to Promax. I don't choose the other three. I don't choose the Verimax. I don't choose the Quatermax. I don't choose the Aquamax because they are techniques when these two factors, the new factors, are uncorrelated. When they are uncorrelated, meaning that when you look at the number just now, if the number was 0.32 and below, this number here, 0.32 and below, then I go up and pick any one of them. And according to most researchers, they go for Verimax. Now, in my case, I get 0.43, meaning that it's related. So I have only two choices here. One is oblimin, another is Promax. I go for oblimin because that is the choice of most researchers. You can go for Promax, no harm. You can try it out when you're free. You can try Promax one time and then oblimin, see whether they are very different or not. They won't be different. Okay, they are almost same. Okay, now I've chosen oblimin, and then I have to go back to the extraction. Just now I didn't know the number of factors, isn't it? So I gave the first choice. Now, since I know the number of factors is 2, I put exactly 2 here. So this time I'm fixing now 2. I know I have 2, so I fix the 2 and then I continue. Okay. Okay, you will get back all the correlation one, exactly repeating, exactly same KMO, exactly same significant. All these are same, the same 2 factors appear, and you can check again. The cumulative is not changed, nothing same. 48, 63. Component matrix, no need to see. Look at the pattern matrix. This is our focus. Pattern matrix means the first factor, the second factor. Okay, what do you understand when you look at? You see, from the 12, the process of SPSS under the EFA has created 2 factors. From 12, now we have 2. 1, 2. Factor 1, factor 2. And what is factor 1 made up of? Factor 1 is made up of item D110, item D18, item D17, item D111, item D112. Correct or not? You see, all these are loadings. We call them loadings for factor 1. And this side, all these are loadings of the items, item loading for factor 2. So this is, you see, the item T11 very clearly telling you that I belong to factor 1. Okay? D110 says I belong to factor 1. I have nothing to do with factor 2. 0 here. And then D18 says I belong to factor 1. I have nothing to do with factor 2. Similarly, this one, this one, this one. But D112, he's not sure. This item is not sure because partially it belongs to factor 1 and another small portion belongs to factor 2. So that means this is called cross-loading. We call it cross-loading. That means it's not only loading to one factor, it also loads to other factor, the other factor. Now, how do you decide? Why do you decide? Do you decide that D12 belongs to 1 or 2? The numbers, you look at the numbers, they're almost similar. No, 4, 9, 4, 3. They are very close. So now we have doubt. So according to the mechanism, what we do, we will remove number 12. I will remove item 12. See, from the 12 items. That means I will redo my EFA, but this time I tick off 12. Okay? You see, that's the only problem in this pattern matrix. The rest are very good. You look at this one, D12, strictly for factor 2. D111, factor 2. D14, factor 2. D13, factor 2. D15, factor 2. So you see very clearly all these are aligned to factor 2. All these are aligned to, except this D12. So my next line of action is I go back, factor analysis, I select D112, and then I take this fella out. Hello, I'm in a class. Okay. Okay, are you with me, class? Are you following me?
Yeah.
Okay,
Yes.
good. Very good, very good. Okay. Don't miss, huh? Don't miss. Okay. Okay, now I have removed 12. You see 12 I brought out here. Inside here, I have now 11 items. D11 until D111. Okay, now the rest all I don't disturb. You know, I don't disturb all this because I leave them as they are. Whatever I fix. That's why I'm using this icon here. I don't go back to analyze. If I go back to analyze and redo like that, no, I don't want. This is another shortcut. Go here, you click, you will have all that you have been doing. See, what you did last will appear on top. What you did before that appear here. Before that, like that. So you go here and then you click only, you get this this small window, dialog box. Sometimes they call it dialog box, sometimes windows. Okay, never mind. So I have removed 12. I'm going to rerun the process. I say, okay, everything will be same. Correlation metrics all same because I just removed it. And of course, my KMO has gone down a bit. Just now it was 0.83 something. Now it's 80 because one has left the ground. One player has gone out of the ground. Significant, good. Component matrix, and then still we maintain the 2, and this one not much change. What is more important for us is the pattern matrix. Pattern matrix. Now you look at the pattern matrix.
Better.
What do you see? Pattern matrix.
It's okay. Beautiful.
It's very clean. Clean and beautiful. Why? Because each item is only attached to one factor. Correct? You see, factor 1 is made up of 1, 2, 3, 4, 5, 6. Factor 2 is made up of 1, 2, 3, 4, 5. As long as you have above 3 and above, it's okay. You can consider it as a factor. If it is only 2, then you better go back and then tell the SPSS, I don't want 2 factors, give me 1 factor. Finish ready. Job. Sometimes the SPSS will create 3 factors. And if you see one of the factors is very minimum number of items, either 1 item or 2 items, we can change the scenario by saying that I don't want 3, I want only 2. So we will readjust to put all the items into just 2. So here is very cleanly saying that my factor 1 only has this item, my factor 2, you see, when I started the questionnaire, I had 12 items and I believed that all the 12 items are measuring my personality. But now the SPSS, using the data I collected, 90 people's data, it is processing and telling me that no, the 12 doesn't go straight to 1, the 12 goes to 2. From the 2, you may go to the 1, but at least now, first phase, you have 2 now. Okay, so I have a factor 1, I have a factor 2. So what is next? I have cleaned, I've cleaned up my pattern matrix, I've cleaned up my items. So in my new questionnaire, if I were to go and collect sample again, I don't have D12. Definitely I don't want D12 because D12 is disturbing. So I removed it. So this process is factor analysis. This one doesn't talk about the relationship the other side. The other side is called inner model. I'm not coming over there. I'm only the side. Between the construct and the items, between the construct. That's what I'm doing now. In other words, this is called measurement model, in the AMOS, in the smart PLS, what I'm doing is the measurement model. That means I measure on the measurement side, not into their real conceptual relationship and all that. I'm not into that side yet. I'm still very early, in the early phase. So now I know my D items, D11, all the items, no more 12, it's only 11, and the 11 are distributed to 2 factors. One factor got 6, another got 5. So I may call this factor 1, I may call this factor 2. But sometimes we go back to the items here and we try to give a name to this factor. Okay? No doubt I told both our personality. So either I go and try to give a name for factor 1, or if not, you just call it personality 1, personality 2, like what I did earlier. That means I don't want to waste my energy looking and trying to get a name. See, I just keep them as personality 1, personality 2. Okay, I want to show you at this moment, I want to show you something related. I'm sharing you with something with you. Can you see my PowerPoint?
Yes, pedagogy 1.
Yes, not pedagogy 1. Pedagogy, oh, okay, good. Okay, I tell you why it's pedagogy, 1 and 2 later. But you see, on my left, it's no more 1 personality now. I got 2 already, 1 and 2. Earlier it was only 1,
Yeah.
So this is the EFA. EFA is assisting me to redistribute the 12 items into 6 items to 1 and 5 items to 2. Okay? This process of exploration is called exploratory factor analysis. Okay? I'll tell you why pedagogy 1 and 2 will come later, but at least the personality item, I've done an EFA and I've managed to come up with just 2. One I call it pedagogy 1, the other I call it pedagogy 2. Okay, we will go back to the analysis and we go back, we push this fella down. What happened? Okay, so fast.
Ladies and gentlemen, the train has arrived. I'm all along the way. Special reminder, take note of the gap between the train
Okay, I'm going back to my data. Okay, I'm going back to my data. Can you see my data now?
Yeah.
Okay, I've come back. You see, this is what we call EFA techniques. You see, before even we go into the real answering of our research question on that, we are still in the measurement. That's why sometimes in the later generation of tools like AMOS, SEM, AMOS, SEM, PLS, all this, we use this, we call this a measurement model and measurement factor analysis. On this side, it's not even going to the right, it's still on the left side. Okay, so the 12 items now I have changed to just 2 items, 2 personalities. Okay, now what I'm going to show you next is that another example. I want to do it for the pedagogy now. See, my pedagogy starts with D21. Okay, all my pedagogy starts with D21 until D20. 20 items. 20 items I have under the pedagogy. Now I have the same question. Are all the 20 measuring straight the pedagogy, or are they going to fall into some factors, some number of factors, 1, 2, or 3, something like that, before they can be merged to pedagogy? So I'm going to try it. I'm going to do the analysis, but this time you see, I'm going to the shortcut analysis. All that is on the window inside, I bring them out. I don't need them anymore. You see, I don't need them. I bring them out, and then in turn, I'm going to push all the D21s, D21 until D220. Okay, 20 items I push inside. Okay, descriptive, same as before. Rotation, I go back to the first one. That means I don't know the number, so I leave it for SPSS to tell me what is the number. And the others all, I don't think I want to do anything here. Options, so nothing. Make it the same. Okay, I'll run it. Running is okay, factor analysis. See, once again, you will see the correlations. As I told you, the correlations, if they are in the median range, that means between 0.3 and 0.7, it's a good choice. If they are very weak, not good. If they are very strong, also not good. What do I mean by strong? That means the value more than 0.7. What do I mean by weak? Value less than 0.3. Okay, so I don't bother much because they are all significant. But look at the significant value, all are good. Look at the KMO. KMO 896, good. That means a sample. Yep, can't see.
No, there are only data view, not output.
Okay, wait. I'm showing you now. Okay, can you see?
Yes.
Class, can you see?
Yes, it's okay.
Okay. What I was talking is, telling you about the relationship here, all the correlation. You look at the values, see, roughly they are all within 0.6, between 3 and 6. So they are okay, very good, because they are moderate values. Okay, and then come down to KMO. KMO is 896, is good. Okay, and then the significance is there, good. So we go on to, like, you see, this one has given me 4 factors. You know, the 20 items now break into 4 factors. See, 4 factors. The first factor, 50%. Next factor, another 10%. The next one, 7%. Another one is only 6%. Okay. Okay, look at this. The pattern also don't see now because I'm going to show you the last one. Look at this correlation matrix. I have now 4 factors. Look at the correlation values. 470, 558, 356, 356, 45, all that. So to me, if I strictly follow that guy, the researcher, 3.2, 0.32 and above is related, 0.32 below unrelated. So I consider this as related. So my action will be go back to this factor analysis, confirm my rotation as related, oblimin, confirm it, and the extraction, I confirm it as four factors now. See, it's not 2, but it's 4. I confirm 4 and I run it. I will run it again. I will run it. Okay, go down, go down. The KMO, no change. It will be around there because I'm not removing anything. Only when you remove this 896 will change. Okay. I haven't done any removal. I'm still staying put. See, same thing, 50, 60, 67, same as before. Okay, now I want to see pattern matrix. This is where you focus. Okay, look at the pattern matrix. Item D212 belongs to 1.
Yeah.
213, 1. 210, still 1. 29, that means item 9 lah. Still 1. Down here is normal 1. This item, you see, it's shared between 1 and 4. So there is some problem here. Then look at this one, beautiful. Only 1. This one, another problem, even worse problem. Got 3 places, it's sharing. This one again, 2 places. Good, 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 not good, 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 good. You see how the distribution goes on. You see, finally, the last few, they are here and here, 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 here. Okay, so I know not all the 20 are good. They do not go to the respective factors accordingly. Some are cross-loading, cross-loading. These are called cross-loading. This is the loading. This is called loading lah. And you can see that they come down in the numbers. The highest loading will be on top. You see, this one is not in 1, 2, 3. No, it's jumbled up. Can you see 12 comes first, then 13 comes next, then suddenly 10 comes here, because they follow the loading size. If the loading is very high, they stay on top. The next high, next high, next high, next high. That's how it comes down. So here you see the highest. Here is a cross loading. Don't take it. Look here. The specific to the vector 2, 837, 764, 704, 397. But 397 is sharing again. So now you tell me, you have seen, isn't it? Now you are seeing it. You tell me which item should I remove? You tell me.
216.
D16.
216.
216. Okay, where is it? 216. Where is 216? Where is your 216? Show me. Is it down? Where is 216? Where is your 216?
Down. I saw it.
You saw it, but we don't see it. Okay.
24.
Is it 216? Okay, it all starts here. It all starts here, isn't it? So let me, because here no problem. The top one, no problem. So whatever problem starts
D25
at this point, or whatever problem starting here only, from here only. Okay, look down. D1, D25 got a problem, big problem. See, 3, 4, 5. They are very close, very closely. I think I don't want D25. So let me remove it first. Let me remove D25 because it's close. The number.
Doctor.
Yeah.
Doctor. There appeared the minus number. So what's the meaning of the minus?
Doesn't matter. Doesn't matter. Don't bother because minus is a different way of loading. That's all. Okay. Don't bother
so
because this is not correlation. This is not correlation.
I see.
Loading. Okay. So don't bother about the minus or plus. Look at the size only. They go together. You see, the size is maintained. It doesn't mean minus means it's another zone. It still follow the number. Okay.
Okay.
What I would do is that I would remove 25 and see how it happens. I run it and see. Don't remove everything that you feel as not good. Huh? Don't go and remove 25, 14, everything that is cross-loading. Don't remove first, because the moment you remove one, the items will rearrange themselves. You know, the process will be rearranged. Maybe after this, after removal of one, everything may be okay. So don't lose the item. You see, some researchers strictly say you cannot remove. But to me, if you have to remove. And furthermore, this construct of pedagogy, I have many items here. Actually, I have 20, more than enough. So I don't mind removing some. If they don't really contribute, if they're disturbing, I'd rather remove them. Unless I have only 3 items, I need to remove, then I will think again whether to remove. Because once you remove from 3, 1 becomes 2 only. Now I have 20. I can easily remove many if they don't, if they are not suitable. So first thing I want to do is I want to remove 25. Why I'm removing it? First reason is that it's cross-loading into 3 factors. Secondly, the difference between these loadings, they are very close. 5, 7, 4, 4, 3, 4, very close, you know, very close. The numbers are very close. If the difference between the numbers, is more than 0.2, 0.2, that means about, if this is 5.7 and this one is less than 3.7, I will keep. Okay, because 5.7 minus 3.7 is already 0.2. So any number less than 0.37, the difference is more than 0.2, so I can keep. But here, no way I can keep. They are very close. It's about 1 plus only, 1 only. So I cannot keep. Okay, I cannot keep. And you see, it's a cross-loading across 3 items. So the best thing is I remove D25, 225. Huh? It's not 225, it's 25 only. That means item 5. Item 5 I remove. 21, 22, 25. I remove. And then I run. You see, that's the beautiful part of this using icon here. You don't have to adjust all this, let them be as they are. You just remove and then rerun. Okay, now look at the pattern matrix. Look at the pattern matrix now. I have removed 1, which was loading into 3 factors. I still have problem with 15. 215 got a problem. But you check here. Can I leave this or must I remove? 65, 36. Difference is more than 0.2. So if I want, I can leave it. Okay? I can leave this and I can take this as if it belongs to number 1. That means it doesn't belong to number 4, factor 4. It belongs to number 1 because the loading here is much heavier than here. So if I want, I can just leave it. Over here also, is it more than 0.2? Yes, it's more than 0.2. So if I want, I can just leave it, saying that this item belongs to this high number. That means factor 2. So I can ignore this. Over here, no, I cannot. They are very close. They are very close. I need to do something. The best thing is remove them. 24, 24, I'm removing now. See, when we really do, it takes a lot of time. 24, I'm removing. You see, I'm going to 24, removing, nothing else I touch because everything is in place. I rerun. Okay, rerun, go to your bit. Sometimes, you see, what I'm showing you is I'm pulling down the screen. Actually, you can go straight to this side and then go and click the pattern, it will appear immediately. That's another way of bringing your table. There are so many tables. If I want a correlation table, I go here and then I click the correlation. If I want a BM, KMO and Butler, I click here, it will appear. If I want to see the number of variances, I click. So you can use this buttons here on the side to get exactly where you want to be. Okay. So now you see this one I ignore. This one also I ignore. But just now the other one I cancel. So still got some fellas disturbing. What about these two? These two, 3.6, 4.6, 5.6, so more than that. If I want, I can leave, but I must take this to belong to the factor 4. Okay. And then this one, 3, 1, 2, and 3, no good. When you have more than 2, you cannot consider the 0.2. The 0.2 is when it's a cross loading into just 2 factors. If it cross loads into 3 factors or more, rather you take him off. Send this fellow home, 216. So I go back, 216, 216. I'm sending him home. We don't allow him to come to school anymore. Okay, go back home. Okay, we run it again. Okay, this is one way of pushing down, or you can go straight to the pattern matrix. Click, you get it. Okay, this one because I ignored just now. Now you see, I still have these two. Once again, you see, this is a cross loading. This is also a cross loading. This is 304050. I can ignore because it's more than 0.2, but this one I cannot ignore because it's less than 0.2. I have to remove. So 217, I remove 17. How many I've removed so far? Any idea how many I removed? 217 is going back home. Rerun. Okay, still 4 factors. What happened? Pattern matrix. What happened? Is it getting clearer? Getting better?
Yeah.
Yes.
Okay, this one got 1, 2, 3, 4, 5, 6, 7 items. Here got 7. Factor 2 got your internet connection.
3.
Okay, second one 3 only. 3
Yeah,
only.
3
This
only.
one got 4 only. So many 3, 3, 4. I can stay put with this. That means my 20 factors are now coming into just 4 components. I don't want to call them as factor, even though the process is called factor analysis. I want to call them as component. See, 1, 2, 3 components. So what I can do, I can just stay with the 4 components, and I may say it's pedagogy 1, 2, 3, 4, or I can reduce this 4 factors into 3. Why? Because I'm exploring. You see, I'm very safe. Nobody can catch me and say, hey, you're wrong. No, cannot. I'm exploring. I checked the 4. I'm not so happy with the structure. One side is heavy, got 7 items. The others all 3, 3, 3. So maybe I reduce the number of factors. So what I do, I go back. I'll reduce. Instead of 4 factors, I go to just 3 factors and see whether anything nice happens or not. Okay, continue. Okay. I want to see pattern matrix. Where is pattern matrix? There you are. What do you see now?
It's very beautiful.
Very beautiful, eh? Okay, very beautiful. So many no cross loading, and there's a cross loading, here. Okay, and then you see this fellow only 3. This one is 3 because 1 is cross loading. Okay, that's the 3 factor. Let me go to just 2 factor and see. Factor analysis. Let me just go to 2 factor and see whether it's even better now. 2 factor, because I got 20 items. If I go to 2, so I get about 10, 10. But I've removed some, so maybe not 10, 10 line, maybe 7, 7 or 6. I don't know. I can't remember how many I removed. I have to recheck. But now I'm going to tell the SPSS use 2 factors to converge. Okay, let it run. It's running. You see, 877 still adequate, still significant. So I can do the process. Go down, 2 factors only, and you see the factor, first factor 50, second one is 60. Okay, look at the component matrix, look at the pattern matrix. Wow, now you see so many to first one, so many to second. And between these 2, the difference is not more than 0.2. That indicates I may have to take this fellow or send this home. 220, I'm sending him home. Him or her lah, home. 220, 219, 220, go back home and I rerun. Pattern matrix, go here. Okay, okay now. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here, Okay, so I've decided to only keep 2. You may want to ask, why now 2? From 4, you come down to 3, now to 2. You see, basically, the loadings, these loadings, if they are higher values, they are better. If the loading is about 0.3, 0.4, it's not a very good loading. You see, this is good, 0.9, 0.8, 0.9, 0.8, 0.7, 0.7, 0.7, 0.7, 0.6. Even this is not so good, but still almost 0.6 watt, this one. So if the loading is higher, it is a better structure, better pattern than having small values like 0.4, 0.3. So that is my rationale why I reduced to just 2. So I'm capturing now my pedagogy of 20 into just 2. I call one pedagogy 1, the other one I call pedagogy 2. So my pedagogy 1 will be 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 4, 6, 9 items. And the other one is 2, 4, 6 items. You see, I have only 15 items. I have removed 5 items. But by removing, my pattern matrix has grown vector. You look at the second vector, 784, 700, 67, 67, 66, 66. You see, very good. All the loadings, these are called loadings. All the loading, they're called factor loading. All the loading size is beautiful. They are around 6 and 7. Very good. 0.6, 0.7. That's a good thing compared to the 4 factors, 5 factors. They become very small. That means not very reasonable attitude, not a reasonable action. So I stay put with 2. So I call one a pedagogy 1, I call another pedagogy 2. But if I want to investigate, I can investigate what name to give this pedagogy 1. So I may look into the item, the actual wording of the item. You see, to name, you have to go back to the original item, look into the wording. How come I have the wording here? Because, you see, I have the wording for every item, I have the full expression, full item wording. How did I manage that? Because when I prepared my data entry, I made sure that I put down all my details in the labeling here. See? That's why I'm very, very happy to see them there. Because I put everything in completely, everything are here. Of course, it takes my time, but I did it very carefully and very neatly. So they are always helping me in my output. The moment I come out with an output, there itself, I can read the original item. Okay? The coding is in front, the explanation is follows. Coding follows coding. So I don't have to go back to my questionnaire and say, oh, D35, go to the questionnaire, read. No need, I don't have to do the questionnaire anymore. I don't have to bring the questionnaire. It's all in my SPSS data. Okay, so that's why when you enter the SPSS data, make sure you do it very carefully. Don't be lazy. Don't think that you're saving time. You do exactly like what I'm doing. Coding is here, all the codings here. We call it name. And the labeling is complete, full. Put in, because you have enough space here. You have enough space. You can go as much as you want. Okay, so don't be lazy, because it's going to help you later. Okay, now going back to my output. I go back to my output. Why is my output? Okay, wait. Where am I? Okay. Data view. Okay. So we are back here. So now what happened is that the pedagogy, the 20 items, I removed 5 items. Okay. So to see what are the items I removed, we can see it here. You can see here on the left or on the right. On the right is a bit jumbled, but on the left you can see exactly what are the things removed, because they will come and fall in place here. Okay, D24, 4 removed, 5 removed, 16 removed, 17 removed, 20 removed.
20.
Okay, so 4, 5, 16, 17, 20. All these are removed. Okay, so what you have here is 15, and they are divided into 2 components, pedagogy 1, pedagogy 2. 2. That's what you are seeing in my, what do you call, in my data here. Huh? See? What happened? Okay, where do I, okay, in my, this what just now somebody asked me, why pedagogy 1, why got pedagogy 2? Because I have done the process. I did it first before I meet you. I already changed the personality to 2 factors, extra factors, and the pedagogy also I changed it to pedagogy 1, pedagogy 2. Then I created 2 models, one with the pedagogy 1 in here, another one is with pedagogy 2 here. Okay, so there are 2 models here. You can see there are 2 models. One is pedagogy 1 with the constructs on the left, and then another one is pedagogy 2. So when I perform some analysis, I mean the advanced analysis like stepwise regression and all that, I noticed that pedagogy 1 is more useful than pedagogy 2. Okay, I worked out on my own, and I noticed that the pedagogy 1 is a better model than the pedagogy 2. Okay, I'll show you later when I'm doing the regression. I'll show you how good it is and why am I saying that it's a better model. Okay, how better model here means that model is a better fit for my data. Okay, better model. But anyway, let's see that there are 2 models now. One is pedagogy 1, another is a pedagogy 2. Okay, okay. Any question, class? Any question? So you see, someone is asking.
Yeah,
Okay.
I have a question. In the pattern matrix, if one item same belong to factors, if the values is positive, point, for example, 0.601, another belong to another factors is
Yes.
negative 0.501. If there are the situation, the item is will keep it or the remove it.
So once you know that they belong to just one factor, we keep it.
Just seem to belong to factors.
2 factors.
Yes,
2
the value is one is positive, another is negative.
Oh, don't worry about the next signs.
Huh?
Just look at the number. Don't look at the negative sign because they mean something else. It's not a number, you know. Don't see them as a number. You ignore the signs.
If there are the values is I understand is the values is very similar or very similar is near it you can to remove it.
Yes, but if they are very close to each other and the difference is less than 0.2, then you remove. There is no other way. You remove. You can't adjust. Because you already got your data. If you adjust, you have to go for new data. You must go back and collect the new data to test whether the adjustment that you did on the item works or not, whether it helps or not. You have to collect new data. Normally we don't do what. You see, when you're doing a pilot test, that's why this all is helpful if you use a pilot test first. When you do our research, you don't go straight into your real study. Just a moment.
Yeah, okay. I understand. Thank you.
Class, the whole procedure of your research, after you have defended your proposal, you have to get ready with your questionnaire, and you have to go and collect about 100 participants, and you call it a pilot study. You collect the data, come back, you put into your SPS, you work out all this EFA and all that. You work out. Okay, you work out to check whether your items were good or not. If they are good, you keep them. If they are not good, you do what I'm doing now. So you see, I don't need 20 now. I only need 50. And I need them in this order. So I will go back and change my questionnaire.
Yeah,
See, I
yeah,
change my questionnaire, I adjust my questionnaire before I go and collect my real data from my sample. That's the important part of the research. You do your pilot. Pilot is actually
yeah,
to
yeah.
look into the possibility of many mistakes, possibility of the validity of the items in the questionnaire and all that. All this will help you. If let's say you don't do a pilot, you go straight, then all these mistakes cannot be adjusted. It cannot be adjusted.
Yeah.
Your
The
data
pilot
is
study
wrong.
is very important.
Yeah, it's very important. You
Yeah.
cannot adjust. You cannot adjust later. That's why the pilot study must use an exploratory factor analysis, after which you go and collect your data. That data will be good. But even then, when you collect that data, the real data, you still have to enter, you have to clean it. The cleaning process is a must. Okay? Okay, any other question, class? So you know, I've given enough examples for EFA, how to do and how to get started. Don't worry, this is recorded. This piece is recorded, so you can play it back and see. But finally, you look into the pattern metrics. Pattern is not pattern, but pattern metrics, and it should be a clean one. It should be a clean one. You can explore that. You see, it's an exploration. See?
Professor?
Yeah.
I have some questions. So can you redo the first step? I mean, for the descriptives, what options should we choose?
Okay, wait. Descriptive. Okay, analyze. Then go to dimension reduction over here.
Excuse me, Dr. Satya. Is the
Yeah.
only
It's not moving. The screen stops.
I don't get you. What are you saying? Your voice is not
We are watching your PowerPoint.
the slide, not the SPSS.
Yeah, I'm going to show you the SPSS data.
We're not can you see it? Yeah. Okay.
Wait a minute. Okay.
Okay.
Something is happening. Okay. See, yeah. My data suddenly turned back. Okay. Wait, something is wrong happening to my data. Wait. What are you seeing now?
We're seeing some column, just a part of the form, just
black screen.
Yeah, it's almost blank,
Yes, okay. Output.
Okay, something is wrong. My data is now completely blocked. Okay, good. Can you see my data?
No, it's just output.
Just the pattern matrix.
Okay, never mind. I show you again. Okay, can you see the screen?
Yeah.
What do you see?
We see the pattern matrix form.
The data.
Is it the data set you are seeing or pattern matrix?
Pattern matrix.
Okay, wait then. I'll go for this. Okay, what about now?
Data.
Okay, data. So I'm going to show you now, but some problem has occurred. My screen suddenly become dark. I don't see the full version. See, I don't see the wordings all, analyze all not there. Okay, never mind. I just show her what is the factor analysis. Okay, whoever asked me, they wanted to know the descriptive, isn't it? The descriptive.
Yeah.
Okay, let me put in the 11 items here first. Sorry, I just reset. I put in all the 11 items. Just now you remember we dropped to 12, D12, correct? So I'm going to use the 11 items here. And okay, I'm going to start with descriptives. Can you see what I'm doing?
Yeah.
Okay, so initial solution is a default. That means the moment I open there's already a tick on the initial. Just leave it as it is. Here, what is important is the KMO. Okay, and then the coefficients. Okay, just like that. The others you put in also doesn't matter. You don't put also doesn't, because they serve some other reasons. I'm not focused on those reasons. So that's why I don't want to tick everything that I see. I don't need all that. Okay. So I continue. Then I go to the extraction. Extraction is where all your items will be extracted, will be converged to some factors. Instead of calling factors, SPSS will call it components. Can you see this word here, component here on here? Principal component analysis. The method of extraction, you have a choice of method. You have principal component analysis, unweighted least squares, generalized least squares, maximum likelihood, principal axis, alpha factor. There are so many methods, but researchers commonly use component. So I'm also using that. Okay. You can use maximum likelihood, you can use other principal axis factoring, but it doesn't matter. You follow the majority, you are always right. Okay. Okay, now here I've selected components, and unrotated is an automatic one, is there. So you click the scree plot and you leave the first one here, because now only you're entering, you're just beginning.
Yeah.
You do not know the number of factors and you don't decide now. You don't decide. What I did, the decision that I made to change 4 to 3, 3 to, that is after I know there are 4. Before that, I dare not do anything like that. I don't want to do. So I just leave the SPSS to decide what is the number of factors that it can extract based on the eigenvalue. So I say continue. Then I go to the rotation. I do not know what rotation to use, because if the number of items, the 20 items or 11 items, if they are correlated, I have one technique. If they are not correlated, I have another technique. So I don't know which technique to use. It all depends on whether they are correlated or uncorrelated. So I have to check whether they are correlated or uncorrelated. And for that purpose, I assume that they are correlated. See, there is an assumption here, because somehow you must choose a technique to display the output. So I'm choosing a technique, direct oblimin, with the belief that it is correlated. But later on, I will decide. So continue, and then options. Of course, the last two. You see, coefficient display format. I want sorted by size, and I will. Okay, let me show you one additional one. If I don't use this last one, the suppress email, suppress small coefficient. Let's see what we get. Let's see what we get. Okay, I'm going to say okay. This is the last one. Last one, I go to the factor components. Okay, look at this. 0.416. 0.416 means it is related. Okay, 0.416 means it's related, because I told you anything more than 0.32 is considered related. Less than 0.32 is unrelated. So now my decision is related. So I go back. Factor analysis, I decide on my rotation technique as direct oblimin. Now I'm confirming this is direct, because they are related. That means they don't fall into the orthogonal unrelated. Oblique is related. So direct oblimin is the method. So I say okay, and I run it again. Okay, where do I go? I go to the pattern matrix. Pattern matrix. Okay, look at the pattern matrix. The 10 items that I did. Do you see the clean one? Are you seeing a clean one? Every item seems to be loaded onto 2 factors. It's not one factor, isn't it? Correct or not? Do you see that? You see, item 10, 110 is loading to this, loading to this. But I told you, when the difference is more than 0.2, you can ignore. That means you take this one. But why should I go through such a difficult problem? So what I do is that when I'm setting the procedure, I'll go to the option here, and then I select the suppress small coefficients 0.3 and below. You see, I'm telling the SPSS, when you see a loading, less than 0.3, remove it, cut it off, don't show. That's my indication. That's my instruction here. Okay, look here, look at here. Most of them are 0.0.0.0, isn't it? So I'm instructing now this SPSS. Suppress means don't show. Don't show when the values are less than 0.3. So if I say continue, what happens is that it will go back to the pattern matrix. You look at the number here, less than 0.3, it won't show this. Less than 0.3 won't show, won't show, won't show, won't show. You see, so many things it won't show, no? This one it will show, show. Okay, this one won't show, won't show, won't show. Do you understand what I'm saying?
Yes, yes, yes.
So what I'm going to do, I'm going to instruct now. So after that, you will see the pattern matrix will be a clean one, better one. So continue. Okay, look at the pattern matrix again this time. Can you see? Can you see the pattern matrix now? You only see one item loading. That means there was a number here, but it was very small. I don't want it to disturb my vision. So I quickly remove it by instructing SPSS, don't show me those numbers. So it automatically didn't show all the numbers that you saw just now. All this taken up. So it's only showing a clean pattern matrix. So that's why when you instruct the SPSS, you give the right instruction, the correct instruction, it will show you the correct output. Okay, now the time is 10:30. We are going for a break. And when we come back, the first 10 minutes, you can ask me some questions about this EFA. If not, I wanted to go to the reliability index. Okay? Is that okay, class?
Okay.
10 minutes for you to ask me questions regarding EFA or whatever we did earlier. If not, then I start with my reliability index or reliability check, reliability test, reliability check, whatever you call it. Okay? I'll see you in half an hour's time.
Half an hour?
Doctor? Huh? In half an hour?
Okay, good. It started again. So that's the reason why I'm able to bring down or reduce my factor, because they are not fixed factors. They're not fixed. See, every time I specify a number of factors, that the whole SPSS will adjust the items for the loadings. So we will adjust. Okay, but bear in mind, when you have many factors, every item also will have some contribution to all the factors. What I want to see is only the heavy loadings. So I suppress, I pull down, I don't want it to see. So I'm telling in the SPS, don't show me small values. So it doesn't show you. Otherwise, it is there. In reality, it is always there. Okay, I'm going to the next one. Any more question, class?
Yeah, doctor. After the EFA, shall we really reduce the item from the raw data?
Yeah, that's what we are doing. Why?
So they are useless.
Huh?
So in the end, shall we reduce the item from the raw data? So
no, because the contribution is not good. You see, the item that you have put in earlier is not good because it keeps contributing to heavily on more than one factor. That's why we don't want. We want it to align to one factor heavily. It can cross-load to many, but there must be a heavy representation at least to one factor. If it is almost equally represented, let's say 0.5 on the first factor, 0.5 on the second factor, 0.4 on the, that's not a good item because the response from the participants must have confused them so that they don't know how to give an answer, something like that. So that's not a good item. If not a good item, you remove it. Okay, that's a whole procedure of cleaning up because we don't want them to contribute or load to many factors. We want the majority of the contribution to some factor only. But the reality will be it will be loading on to many, but the numbers, other numbers all will be small except one number big. Then it is okay. Okay.
Professor, in
Yep.
in your assignment 1, you ask us to do some items from Q1IM to
Yes, yes.
Q2IM.
The data I've given you, the data I've given you.
But there are some Q1A, and I mean there are some other.
Yes, yes, that's a different set. You will see Q1A, Q2A, 3A, 4A, and then you will also see Q1IA, Q2IM, something like that. See, that's a different set. So you have two sets right now. Just pull in one, pull in the other one, and do like that. Okay.
Oh,
Actually, I have an example from there in my lecture. Later, you just wait. You wait until I show you the Q1A, and then I will ask you to do the Q1IM. I show you one, you do one. Okay?
Okay.
Don't worry,
Thank
don't
you.
worry.
Thank you.
It's in the reliability side. Okay? I will do EFA followed by reliability. Okay, now you see, now is look at this pattern matrix. According to the pattern matrix, I have divided the personality into two factors, personality 1 and 2. So my personality 1 now consists of D10, correct or not? D10, is it correct? Hello, class?
Yeah.
D10, some more?
Yeah. 2,
18, then 17,
16.
1719. No, are you watching my screen? Oh, sorry. D8, D6, D8, D6, D7, some more?
9,
9, some more?
11,
Okay, some more?
12.
11 and 12. 12.
Yeah.
Actually, 12 is we removed. You remember 12 because okay. Somebody asked me just now. You see, 12 there is a cross loading, and the loadings are quite the same. So this is not a good item. That's why I'm removing, because it doesn't show it's belonging to any one factor. It shows like I belong to two fellas. This fellow also I have contribution. The other one factor 2 also. So that kind of items is not a good to measure. It doesn't measure any particular factor. It's measuring 2 at the same time. So that's not a good one. So by right, I should drop it. So I'm dropping D12. So in my D personality 1 factor or component personality 1, I have 1, 2, 3, 4, 5, 6 items only. And they are D10, D110, 8, 6, 7, 9,
11.
and 11. Okay, only 1, 2, 3, 4, 5, 6 items. Okay, remember this. Okay, and then my personality 2, the other factor, personality 2, I have 2, 1, 4, 3, and 5. Okay, now do you follow me? Are you with me, class? Are you with me?
Yeah.
Okay, so now I'm going to start my reliability test. You see, now what I understand is that the 6 items that I'm seeing now, the 6 items that I'm seeing on top, the D10, D11, D9, D7, D8, D6. These 6 items, they belong to, or rather they contribute to factor 1. And I call this factor 1 personality 1. So what I'm going to do is that my EFA has given me these other items that load on to factor 1. Now my next procedure is I want to check how good these items, or how much I can rely on these items, or what is the reliability of these items upon my personality 1. That means how well my personality 1 can be measured by these 6 items. So that's why I'm going to do a reliability check. Look at how I do. Go to analyze. I go to scale. I go to reliability index, the first one. So I get this dialog box. Okay. You see a dialog box, I'm putting it aside. So I'm testing the reliability of these 6 items upon my personality 1. So what are the 6 items? First one is D10. Got it, not D10. Okay, we come down from D10. Huh? Sorry, so fast. Okay, D10, push in. D11, inside. Huh? Then what else? D10, D11, D9. Okay, D9, I'm pushing in. D8. Okay, D8. Sorry, yeah, D8. D7, yes, D7 also going some more. What else? D6 on or not? D6. D6 is there. D6 also going. Done and all the 6 are inside. Huh? You see 10, 11, 9, 8, 7, 6. So these are the 6 items that contribute or that loads onto factor 1. And factor 1, I'm calling it as factor 1, I'm calling it as personality 1. I'm going to check whether these 6 items are reliable measures for factor 1, which is personality 1. So I'm going into the reliability analysis, reliability test, or reliability check. This is the procedure, statistics. You see, you can have the correlations, you can have the scale if item, and the rest all not so important, because we are going to use this one very carefully, and we can just look at the correlations there, item correlations and all that. Okay, even this also you can click. So just remember 1, 2, 3, 4 clicks on here, continue, and then say okay. And here you see the model is alpha. That's why we say Cronbach alpha. Whenever we say reliability, we use the term Cronbach because that's the measure we are using. There are other things, you know. There's a split half, there's a Gutman, there's a parallel, and then this is a strict parallel. And we are only using alpha. Okay. So you will see a few tables. The first table is case processing. I mean, how many cases came in and all that, valid case, how many, any missing value or not. You see, once again, the missing value will be shown here. So if you had cleaned up your data earlier, you need not worry about missing value, all taken care of. See, your missing value is 0, the data is clean, no outliers, no unusual numbers, nothing to do with the reverse coding effect and all that. So you are safe. That's why we have to do that. And then when you come down to the second table here, this second table, this is where you have to read. This is what we mean by Cronbach alpha for core reliability. 0.852. Anything more than 0.7 is acceptable. 0.7 is already good. 0.8 is even better. Okay, 0.9 is good, very strong, but cannot be more than 954. Okay, don't take it more than 95 lah. If it's 0.99, then no good, especially for researchers like us. When you come up with your own instrument, 99 means something not good lah. Okay, it cannot be so high. 99 is very close to 1, means perfect, you know. Do you think you can come up with a perfect questionnaire? Cannot. So let us be in the range more than 7.7. So 0.852 is already good. Now what do we do next? This table not so important. The first table. Second table is important because this is where you want to see Cronbach alpha value, and this will tell you how many items you put inside. Okay, don't worry about the middle one. Go for this. Go for this. Okay, and then here you see this is item statistics. That means each item, what is the mean standard? This is also not important. This is inter-item correlation. That means you have 6 items, each item with another item, like D10 with D11, D10 with D19, D10 with this. You see here, the values have to be correlated, but cannot be over correlated, meaning that your value here, whatever you see here, cannot be more than 0.7, 0.8 like that. It's not good. Because if 2 items are shown or come out as point something, 0.7, 0.8, or even higher than that, that means they are almost similar. Almost similar. So you don't need to. You can drop one. That's the philosophy. You don't need two same items to measure any construct. We want, as far as possible, it can be related, but cannot be over-related. I mean, it's overly relative. Okay, so the values cannot be more than 0.8 or 9 like that. This is okay. Less than 0.7 is okay. So the criteria is less than 0.7. Between 0.3 to 0.7, they are okay. Inter-item, that means item to item. This table is item to total. See, first item to the total. Okay, but here also you don't have to see everything. You go to the last column here. This is an important column. Cronbach alpha, if the item is deleted, meaning that when you look at the first cell, that means the first item lah. If I remove D10 from my list, what will happen to my Cronbach alpha? It becomes 0.811. Can you hear me, class?
Yeah.
Okay, yeah. So in the reliability index, as you process, you get this output. This one will tell you this value. This is your Cronbach alpha. You need to report this value. Cronbach alpha reliability equal to Cronbach alpha equals to 0.852. So 852 is a strong one, strong reliability. Very good. Okay, but how was it good? Because of the 6 items. So we come back to the 6 items here, not here, but down here in this item total statistic. Look at each item and the corresponding cell over here. This is Cronbach alpha. Just now we saw how much? 0.852. Okay, Cronbach alpha. If I drop this, so let's see. If I drop D10 from my list, what happens to my Cronbach? From the 0.852, it comes down to 0.811. I can show you. If I go back and drop this, my value for the Cronbach alpha here, on top here, it will turn 0.811. It won't be 852. Which is better, 52 or 11?
52.
Yes, 52 is higher. So I want my Cronbach to be higher. So what I do, I don't do the mistake by dropping this. If I drop this, it goes down. So I don't drop, I keep it. Go to the next one, 830. If I drop, 830. Presently, 852. So I don't drop. I don't drop. I don't drop. I don't drop. That means all the 6 I have to keep. Okay? So you see the reliability of all the 6, component 1, composite 1 is 0.852. And this is advising me, don't drop any of them. This is possible because I did an EFA. I did an EFA, I cleaned up my pattern matrix, so I know exactly my 6 items only are contributing heavily on factor 1. So because I did the EFA so well, that I clean it so well, that's why the reliability is so perfect here. Nothing to drop. I don't have to drop anything. But then, in a scenario where you didn't go through the EFA, you have no idea of whether all the items were useful or not, you put inside in your reliability, what happens is that some of the items will tell you it has to be dropped. Because the value by dropping the Cronbach will go up, indicating that this is blocking the value from going up. So you drop it, it becomes better. So that indicates you have to drop. So like our case, since I've done the EFA and I make my pattern matrix very, very accurate, rather accurate. So I do not have the issue of dropping any of my variables or items. Okay, let me do one more. The other one. Let me go back to the other one, and I do. Okay, that means all this done already. Yeah, all the 6 done already. So now I go back to the same D1, but this time, what are the values? My second one. Second one is 2, 3, 4, 1, 2, 3, 4, 5. So I take 1. Second factor, personality 2. 2, 3, 4, 5. These are the items according to EFA. Push in there, don't disturb anything. It's all set. Okay, go and say okay. Once again, you will see all similar tables. The first table on case processing, the second table is important. Look at the Cronbach. 0.865 is another beautiful number.
Yes.
Strong. Okay, so go down to the last table. Look at the Cronbach alpha. Remember this, 0.865. Okay, now what happened? If I drop item number 1, 865 will come down to 860. Shall I drop or not? No, I cannot drop because it's coming down. When I drop, it comes down. I don't want that. So I keep 816. No, I don't drop because if I drop, it's coming down. 839, still again. If I drop, it's coming down. Drop, coming down, drop, coming down. You see, thereby telling me that keep all the 5. Because if you keep, your Cronbach is 835. Okay, so this is called reliability index, reliability test, reliability check. Okay, any question, class?
No.
Okay, supposing you never go through the EFA, you never cleaned up the metrics, pattern metrics and all that, you have no idea of which item is good, which one not good. So you may have to drop them accordingly. Let me show you something like that. Okay, something that never went through the EFA. Let me go through. So what I do, I'll go there, I'll open a data. Maybe I go to what Juliet was saying, the survey. I think it's a staff survey. Yeah, I think that's a one. Right, Q1A, Q1IM and all that. Okay, I'm going to do this. See, what I do is that if you really look at the variable view, you see, this person, whoever did this, they were a bit lazy. They never write anything in the labeling here. No doubt they put some code here, but nothing is associated or nothing is followed up with the code labeling. So I have no idea, what this Q1A means, Q1, I don't know, because I don't know. It's not my data. Somebody said, yeah, I'm just collecting. So you see, I don't know what is Q1A, I don't know what is Q9. So this is not a good way of doing. If that data is yours, you make sure that data is very clean, is very complete, comprehensive. You know the coding, you know the actual phrase of your item. That is beautiful. Okay, that is beautiful. So not like this. There's no good. To me, this portion, nothing is filled up, so it's not finished yet. Okay, all the others can be okay. This is all okay. This is all okay. This is all okay. All the rest are okay. And here also he has named ordinal. Let me see, he has done something lah. But here he hasn't done anything. So when I do a analysis, any analysis like regression or t-test, whatever analysis, this part won't come out there. So I have no idea. I will see the coding here, but nothing else. Okay, so let me now do a reliability analysis, reliability test, reliability check on the Q1, all the A's, all the A's, 1A, 2A, all that. I have 10 of them. I have 10 items here. So either I can go from beginning or I can use the shortcut. Reliability. Okay, now you see all the QNs are here. So I need Q1A, push in, Q2A, push in, 3A, push in, 4A, push in, 5A, push in, 6A, push, 7A, push, 8A, push, 9A, push, 10A, push. Okay, 10 items. These are actually items. You see, there's no word associated with that because we don't know. The guy didn't fill up all that label. So I don't have, I only get the codings. So statistics, still the same. Oh, gone already. Gone already. So I have to redo. Okay, item scale. Then correlations. Nothing lah. Okay. Okay, then it's alpha. Then I say okay. You'll see the same one. Look at this 852, correct?
Yeah.
Cronbach 852. It's good lah. Considered all are good. But let's look at the item total. 8, what is that? 852. Good. 852. Okay, look here. Can I drop this? No. Because if I drop, it goes down. Can I drop this?
No.
Can I?
No.
Can I?
No.
Look here.
Yes.
You see?
This one.
You see? There is one item here, which when I drop this 8A, it goes up. That means this item 8A is disturbing my reliability. It's bringing down my reliability. So according to this analysis, I understand that this has to go up. The 8 must go up. So I have to redo analysis, take the 8 out, and then run it again. Okay, what happens? You see, now it has gone up 878, isn't it? 878, and then down here 879, 69, 60, 49, 65, 67, 55, 861. All are less except the first fella. First one, the hour value is 878. This one is 879. What are you going to do? If you drop, it goes up by 1 small unit. You don't drop it as at 878. What is your decision? You want to drop or keep it? Class, tell me. You want to drop or you want to keep it?
Keep it.
Keep it. Why? Why?
Drop.
Because why?
We can contact more data.
So why would you keep it when it is helping you to come up a bit? 879. Otherwise, it's 878 only. Now you drop it, you get 879. Isn't it good?
879.
Oh, drop it.
Okay, drop it. Finally, you change it. No, actually, we can keep. I can keep it. My reason will be not much different. 878, 879, not much, isn't it?
Oh.
So I can keep it. Okay. You see, it doesn't mean we should immediately drop because the number, but you look at the difference. If I drop it, I get just 1 point extra. 878 becomes 879. That's all. Okay. And 879 is not 870, it's 0.878. Change to 0.879. So it's not a big thing, you know, it's a small increment. So I can choose it, I can leave it there, or if I want to drop, so I can drop. But before dropping, you check the number of items. Huh? You see, you check the number of items. There were 10 items. I dropped 1 just now, so now it's 9. You drop 1, it becomes 8. Still okay. As one factor, it's okay. I didn't do a factor analysis here, you know. I went straight to the EFA, into the reliability. Supposing I do an, what they call, a factor analysis. Let me go and redo a factor analysis. Okay. What I do, I push in all the ones, A's, 2A, 3A, all the A's inside, and factor analysis, EFA. See whether I can get a beautiful matrix or not. Okay. 7A,
8A,
9A, and 10A. Okay, I have all the 10 here. As usual, the descriptive all will come. Question, all this came on, all that. And then the extraction, I'll leave it to SPSS because it's a beginning, you know, beginning, and then script plot I want. Okay, and then I go for the rotation, go for the publishing first. Okay, and then the options I suppress because the reason is that I don't want to show you small numbers. Okay, so my suppression criteria is 0.3. Anything smaller than 0.3, I don't want to see. Okay then. So my correlation matrix, you see, it's still 790 is okay, you know, adequacy is okay, significance is okay. So you go down, now got 3 factors. Just 10 items got 3 factors, you know.
Yeah.
This is where the human decision will come in. You see, do you think that you need 3 factors to be used when you have only 10 items? Then you divide also, you will get 1 factor 3, another factor 3, another factor maybe 4. That's all. So to me, that's not a very good idea. Okay, here the difference is about 13. Here the difference is about quite a good difference. Okay, script plot also tells me 1, 2, 3. See, okay, and then the component matrix. Look at the pattern matrix. Look at the pattern matrix. It's clean here.
Yeah.
Clean here. Not really. This one is, you see, Q1A is disturbing, but the difference is more than 0.2. So if I want, I can keep it. I can keep it. That means this Q1A belongs to 2. But look at the third factor. If I don't use this, third factor remains with only 1 item. 1 factor or 1 component having only 1 item. Nobody wants it. Nobody likes to see that. So ultimately, I don't need 3. I have to go back to just 2. So I'm going to go back to the SPSS. I'm going to tell the SPSS, give me just 2 factors. Okay, the second one, and then decide 2 factors. Why I'm deciding? Because the third factor that SPSS is giving doesn't have items, only 1 item there. So I don't want. I want at least 2 or 3 items in a factor. So continue. Rest, I'm not disturbing. Continue. Go down, go down, go down, go down. Okay, now you see I'm decided 2 factors only, 46 and 59. As long as the cumulative figure here, this number, more than 50, we are okay with this model. Okay, we are okay. Unless it's small. Now you see, because I'm indicating, you see, script plot is still telling me 1, 2, 3, but I personally decided 2. Okay, now look at the pattern matrix. This is very clean. It's not very clean. And still the 7A is disturbing now. And my 6A is disturbing. Okay, 4, 8, 4, 5, very close. I need to do something. 4, 5, 4, 9, and 3, 6, 8. Still disturbing. Now you have 2 items to remove. Don't remove both together. Okay, don't remove both. We know that we have to remove, but remove one that is very weak. Okay, this is very close. This one is even closer. So I think I may want to remove 6 first. So I go back, I remove 6A. I remove 6A. Okay, and see what happens. We just see what happens, whether there's a better matrix or not. Is it better?
Is that
Yeah,
good?
just now you see, I saw 2 that needed to be removed. I don't remove immediately the 2. Try 1 first. Try 1 which is very weak. Remove and see how the items behave, because they will react again. The items will re-function and redo. Okay, so now I know I need 2 matrices or 2 factors. 1 is this one. 1 is this one. Just 3. 3 and above is okay, not less than 3. So I can use this as a second factor. I can use this as a first factor. Okay, let me go and do a analysis, reliability analysis now with this new arrangement of factors. So I'm going back to here, reliability analysis, okay, and then I'm going to put 6. Sorry, yes, I'm going to put 5, 10, 9, 4, 3, and 7. So 1A goes up, goes out, 2A goes out, 3A also,
8.
3 also goes out, 4. Is it here 4?
Yeah, okay.
4 must go out also. Let's see, 5 remains. 4 goes out. 5 will remain. There's a 5. 10 remains. 9 remains. 4 is inside.
4.
Sorry, 4 bring in. Okay, then 7. 3 here.
3.
3 is inside. Is it there? No, just now we pulled out 3. Okay, 3 also come in.
Okay.
Okay, that's all. 7? 7 is there.
6 is more. 6.
6 is extra.
Yes.
It must come out.
6,
6 must come out, eh?
Yeah.
Yes, yes. So we bring out 6. Now how many? 6.
Okay.
Exactly 6, eh? Okay, beautiful. Now I know. Now I know that the Q items being considered under 2-factor now. So I know that one of the factor is what we are investigating now. So I'm going to check now with the reliability index, the same one, the scale, everything. And I'm going to run it. Look at the number here, 876, beautiful. And look at the figure here. Do I have to remove any? Number 1, I don't remove because it's going down. Number 2, if I remove, I get something about 004 units inside. Okay, 880. My value there is 876. This one I cannot drop. This one I may drop, but I can decide whether to drop or not looking at the differences. The difference between this value and that value is only 004. It's very small. Still for me it's small. So I can just. So my items now under my reliability index, reliability test tells me that these are the items that go for Q first factor. Okay, Q first factor. Similarly, I can do for the second factor. See, I can do a second factor. Also reliability analysis. I don't want all this. Push them all back. And then collect all the other remaining one. 1A goes in, I think. Is it true? 1A goes in?
3.
Do you remember this one? Do you remember? Wait, do you remember what was our
Q.
okay,
QA.
2A.
Sorry, sorry. Where was our pattern matrix? Pattern, just the one. Okay, okay. Q1, Q2,
Q8.
Q8, Q1, and Q2.
Yeah.
Q1, Q2, and
Q8.
Yes. You see, 1, 2, 3 all don't come here, no. Finally, number 8, item number 8 is coming in. You see, that's why we cannot say when we assemble our items, 1, 2, 3, it doesn't mean they will go accordingly, no. It can be a jumbled up because it depends on the data. It depends on the response. So I'm going to put in 8 now. Okay, 8A, push in. Statistics remains the same, so we just find out now. Look at the figure. What is this?
Is not good.
Is it a good one?
No, the value is
0.92. That means it's like 0.1. Okay, 0.1. So what does it tell you?
These 3 items is not good.
These 3 items are not really measuring anything, isn't it?
Yeah.
You have a choice now. Now you see, now another decision comes in. Whether I want to keep 2 as the 3 or do I want to combine all as 1? Okay, I may try it. I may try with 1. Okay, let me put everything in 1 and see whether they are good or not. In my factor analysis, I just say I want only 1. Okay, factor analysis in the extraction, I say I only want one factor. Okay, I only want 1 factor, but make sure all are inside. Don't remove any yet because okay, and then the rest all I think rotation is okay. Option also, option also suppressing, correct. So let me run and see if I decide to only with 1 factor only, it contributes only 46%. Okay, you don't see any here because there's no rotation happening, only 1 factor. So we just take it, and then we will do a reliability analysis on all these items, all this 1, 2, whatever remaining we push lah. Okay, we push all that.
2, 3.
Yes, I'm going to push. 2 is there. 3 I push.
4,
4 I push. 5
5,
I push.
6, 6,
Wait, sorry, huh? Where is 6? 6 I push.
7,
7 I push.
9,
8.
9,
8 is already there.
8,
So 9 is I push, and then
10,
finally 10 also I push. Okay, now I have all the 10 items. Same statistics there. Okay then. See, suddenly the value has come so big. Correct.
Yeah.
You see, the value is now 852. So this is more meaningful. You see, this is how we create meaning for our analysis. It's not simply following the instructions, simply following. So we create meaning. Now we know that if I keep all the 10 items, my reliability, but still not very sure yet, because you need to go whether all the 10 are useful or not. So you go and check this one. The value is 852. Remember, it's 852. Check. Okay, dropping. So don't.
Q.
Coming down. So don't drop. Coming down, don't drop.
8, yes,
This one, you see, this one is
it's drop.
going up from 852. It goes up to 880 if I drop. So I think I need to drop this one. Remember, I have to drop 8. Then see what more I have to drop. I think nothing.
Others is okay.
The rest all nothing. So 8 I must drop. So naturally 8 will go off. You see? 8 has to go off. Where is number 8?
8.
Somewhere here, isn't it? 8. Okay, I'm sending 8 back. Now I have only 9 items. 878. Correct, huh? 878.
Yeah.
And then let's see anything to remove or not. 878, 87. Sorry,
Okay.
are we at the same place? Correctly. Okay, 878.
878.
879, no need lah, because just by 1001, no need. 860, 849, all are good.
Yeah.
Nice.
Yeah.
Okay, so now I know that my Q is less 1. That means 8 I've removed. Okay, so this is how we do it. We have to do it. You can do an EFA to confirm on the factors, but even then, when you come into the reliability, it will tell you a different picture if the items do not measure well. If the contribution is so little, reliability won't appear, won't happen. Okay, so reliability index is carried out this way, but always remember this is not mechanical, meaning that you do this, you click this, click that without thinking. I don't advise. Make sure you are always thinking about your model. See, all this number of factors, some of you asking me, why am I, can I do a reduction in the number of factors? Yes, you can, provided you have enough reading. If you know the area, the topic, and you have done enough reading for the literature, you will be in a better position to decide on the number of factors. You will be able to decide whether you should have 2 factors, 3 factors, or whatever. Only when you don't have any idea, you follow quite mechanically. But if you have some idea, some reading, some articles that say it has this many factors, that many factors, and then you just follow your knowledge base, not the mechanical SPSS. Okay, the mechanical will of course give you some answer, but rationalize with your understanding, your knowledge of the theory. Theoretical knowledge is important to decide. When it comes to decision, your knowledge is the best. Okay. Any question now? So you know how to do EFA, you know how to do reliability test.
Yes.
So we are only going to learn in the afternoon session. Sure, we will learn the regressions, all the different types of regression techniques, the family of regression, linear, standard multiples, and stepwise, hierarchical, all that we will learn. And then I will show you some examples where the researcher decides to do something, and then he or she will have some questions, and then I'm going to show you how to answer those questions, which analysis must do, which test must use. I'm going to show you. So if you have learned until today's lesson, you should be ready for the analysis. There's nothing to stop you. to me, as far as I know, if you understand as how I've been continuously teaching you, coaching you, you shouldn't have any problem in the data analysis for your questions. What you want to find, what analysis to do, what you want to find, what analysis, all that is clear. So by the end of today, I will make sure that you understand, you know what is your data analysis and how it looks like. Of course, whatever suggestions I give for the analysis is only meant for SPSS. Remember that besides SPSS, there are other tools. The SEM, structural equation modeling, there are two types. One is called covariance based, which uses AMOS, AMOS, analysis of moment of structure. And then the variance based SEM, which uses some tools, but one of the main tools that lately being developed and very fast improving is Smart PLS. PLS stands for partial least square. So Smart PLS is another tool. Those tools can be used for even a smaller sample size. Of course, earlier on, when we want to use SPSS, the sample size is very important, must be big, 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 big. Even normality tests also, we do. But when you come to the Smart PLS, it doesn't care for normality. Any shape also you can do. These are the improvements in the analysis area or discipline. Those days, we always say, oh, it must be normal, then only I can use the parametric test. But the Smart PLS, it doesn't care whether your distribution is normal or skewed. It can give you an answer, okay? Isn't it better? You don't have to bother about the testing for normality and all that, because any distribution can allow or can be allowed for Smart PLS. It will take in any, even skewed one, even the sample size not big enough, it can do for you. So don't you think that's an improvement? That should be an improvement, because that's a good thing. You don't have to hunt for very, very difficult samples. However, do not misunderstand that a Smart PLS is advising you to go for small sample. No, it never say that. The bigger the sample, the better and more accurate your calculations, your values will be. However, when you cannot get enough sample, when you cannot, let's say the normal SPSS requires to have about 300 sample size, 300 people. Let's say you are doing a study maybe on the institution. For example, let me put it this way. Let's say you're doing a management issue study on organization, and you know that there are not many organizations. We don't have many. Let's say you have only about 200 organizations in your area. How to get 300 when you only have 200? So automatically SPSS won't allow you, okay? Because the other tests won't allow you. Even AMOS won't allow you. SEM also, but AMOS won't allow you. It needs a bigger sample. But the new version of Smart PLS allows you, because it told you right from the beginning, even if you have small sample, come to me, I will help you. But don't take me wrong by going only for small sample. When you really cannot get sample big enough, when you really cannot, then bring it, I will help you. Smart PLS. But AMOS, no way, no negotiation. You have the number, you come to me. No number, don't come to me. So that's why Smart PLS is getting more and more popular. And because it can do the same thing as AMOS, it can do exactly the same thing as AMOS. And they are fast developing the Smart PLS, very, very much faster. It only in the last few years, even though it started in 1990, but those days people dare not use or rare to use. You don't see many articles using the Smart PLS, but now it's getting very popular. And I'm using it. I'm using it for my analysis. I'm also advising and teaching, coaching my students to use Smart PLS. So I'm teaching them how to use Smart PLS for their analysis. Okay, but what I'm going to show you end of today is that data analysis using SPSS. Okay, if you are using SPSS, what will be the data analysis that you will use? Okay, I don't have time to introduce a smart PLS for two reasons. One is that I don't have time, because you see, this is the last week. Until now, we are struggling to finish regression. And Smart PLS is one additional tool that needs at least 1 or 2 days, two sessions. One session, at least 3 to 4 hours, because I can't just show you 1 or 2. I have to show you how to do a relation. I have to show you how to do prediction. I have to show you on the model fit and model structure and all that. So it takes me easily 2 sessions, 2 workshops. So I cannot bring it here. Okay. Of course, I have an intention of doing some workshops under the name of data analysis using Smart PLS workshop 1, workshop 2, which will come later. Okay, which will come later. I will specify the dates, but if it comes somewhere near your data collection or just after your data collection, that will be very useful, because our mind will be on the analysis, and you already have some data with you. So that's the time you will need this kind of analysis. If I teach you now also, you don't have any data, you have no urgency in learning the skill, you won't learn. We are adults, we are like that. Adults, when we learn, when we need it. Okay? When we need it, we learn. We don't need, we don't learn. That's adults compared to students. Okay? That's andragogy. Learning depending on your needs. You need it urgently, you will go for the learning. You don't need, if you think that you can wait 6 months to know the language or skills, you will wait until 6 months, then only you will start learning. So that's the adult problem. I wouldn't say problem, but that's the style adults learn. So I'm waiting actually. I'm deciding to run a workshop, 1 or 2 workshops on data analysis using Smart PLS later. Okay, later. But I would prefer when you have collected the data. If you have collected your data and waiting for the analysis, that's the right time. I teach you so you can use your data, your own data, to do your analysis. That would be the best thing. If I give you a data, you do is practice. Okay, and if you do it so early, that's one thing. So one reason why I'm not teaching is that I don't have time, and it needs that many. The second reason is that Smart PLS is unlike SPSS. It is a costly tool. I have the license to use. Maybe I should just show you. You may wonder what is Smart PLS. Let me show you. Okay. Can you see my screen now? Do you see my screen?
Yes.
Huh?
Yeah.
My desktop, what you are seeing in my desktop, look at this side there. Can you see this symbol on my left? Smart PLS 3, yes, correct. So I'm going to press this, I'm going to click this, and it's going to open. It's going to open. It's a costly one. I have the license to use. I bought this license. I can use it for 1 year. I just bought, I think, early this month or last month. Before that, I was using the free version, which they give you 1 month. So this is the front page of Smart PLS. This is the front page. You see the front page? You have some projects. I have some projects here. And then this is your workspace. They call it workspace. That means this is where you bring in your model or whatever. Okay. And when you're doing, you will see something like this. I'm going to show you something, some projects. Let me show you some of my projects. Okay, new model, GG raw. Okay, let me see. Nothing happens. Okay, there you see. Can you see this?
Yeah.
You see, this is how we create. I haven't created. I have not connected. You see, they are all rate, but you see how the variable, the construct. This morning, somebody, I think Lee, he asked me about the relation. This side to your left, this side is called measurement model. Your construct is here, the items, the questionnaire items are here. You see, the construct, the item. But when you're connecting a construct to another construct to another construct, that is called inner model. It's called inner model or structural model. Structural model or inner model. This outside is called measurement model or outer model. The EFA is done here, this side, not this side, this side. Whatever you do here, it comes under the smart PLS the later when you are connecting. You see, I can connect all this, then they will turn green, blue. If I connect, it will turn blue. Now you see it's not connected. So let's say I connect. I connect. Are you all watching class?
Yeah.
Okay, let's say I connect. I connect all of them. This is my pedagogy. These are the other variables. I'm connecting one by one. See, until now, they're not all connected. That's why it's still red. But when I finish connecting the last fella, sorry, when I connect all the last fella, then you will see it turns color. Okay. This one still has a connection. Sorry, oh, good. This one can still be connected here. Can also connect here. See, I can create this part. We call it part, you know. These are called parts, sorry. These are called parts, part models and so on. Okay, one more here. Okay. You know why the others are remaining as gray, red, while these are turned blue? Do you know why these are turned blue? This from red turned to blue when I connect, but the others are not turning. Do you know why? No idea. Okay, because this one, I just name it only. I have not given the variables yet. Like this one, you see, latent variable, latent. I haven't given any name yet. Pedagogy, I brought in all the pedagogy items, indicators, and push it over here. Like this one, all I never. Let's say I have, this is personality, the two personality. Let's say I go to student knowledge. I think subject knowledge is D3. All the D3s are subject knowledge. Let's say I bring in all the spellers D1, 3.1, 3.2, 3.3, 3.4, 3.5. I push them with the thing. Okay, there you see, the moment I provide my, what do you call, I provide my, sorry, sorry. Okay, I have to, you see, when you're using some function like connection, you must go and redo, what I say, it's not redo, undo, you must undo by select here. Then only it becomes a precursor. Okay, now this one, I can give a name as rename as what I call, it was a subject knowledge, yes, subject knowledge. Okay, so we will come with the knowledge. And then let's say I want to give this a student knowledge. Student knowledge, I think it's all the D4s. So take all the D4s, D4, 1, 4, 2, 4, 3, 4, 5, bring it over here. Okay, that also turn yellow because they do not have any items yet. I haven't defined them with the item. That's why they still remain, even though I've connected. They have connected. So this one, the last fella, is context knowledge. Let's call it. This one is student knowledge. Student knowledge. Okay, student knowledge. Okay, sorry, I pressed it wrong. Student knowledge. Okay, there you see, change already. This one I'm going to give a name, context knowledge. Context knowledge. Context knowledge. Okay, give a name. There, context knowledge, but still red because no item yet. I think context knowledge comes as 50s, all the 50s, like 51, 55 until 55. Yes, 51, 55, all this. Okay, all this comes as context knowledge. So I put, okay. You see, when I put this, it by default it will come, it fall on the left. But I can't keep like that because it's disturbing my other variable. So I have to push this somewhere. This side is blank, so I want to push this to the right. So you double click, and then you go to align to the right. Then you move, it will move. So all these are possible here. The advantage of using Smart PLS or even MOS is that you will see the concept framework. At the same time, you will see the values. In SPSS, the conceptual framework is elsewhere in your words. The values only you see on the SPSS, like reliability, all this relationship also. The values are somewhere. They are separated. But in the Smart PLS or MOS, what happens is that you will get the conceptual framework, and on top of it, you will see the numbers. Okay. So let me fill this fellow also, and then I show you how the numbers can come while waiting. Okay, I rename this. What is, I still haven't put the no self-knowledge, no self. Okay, I haven't put that yet, so I'm going to put that. All the 60s are for the self-knowledge, so I'm going to transfer them here. You see, this 5 go to this one. Okay, now you see everything is same color, and you see again it's blocking, so I can push this one up. I can push this one up. So right click, align to the top, so it will go up. You see it going up. Okay, it's gone up. So I have set them, and I can just push them. I can rearrange them, see, so that it looks nice. Okay, maybe I push this fella out, this one inside him. You can do all this. You can do all this as you like, you know. See, this one is pedagogy. Okay, so I have a model now. See, this is called a model, and all this one, this side is called measurement model. Measurement model. Measurement model. So when you are testing whether these items contribute to this or not, whether these items contribute to them, we do a factor analysis like what we are doing in SPSS. But here, the factor analysis, this Smart PLS will do for you. You can do it here straight. So there will be values given here. So let me just show you some values. You see, this is called path. This is a path from this variable to that variable. Actually, DF1 means it's actually personality 1. Let me rename it. Personality 1. Okay, I think that's it. That's the term. So it becomes personality 1. This will be personality 2. Are you watching a class? So silent. Are you watching me?
Yes, we are watching.
But don't understand it.
Never mind, never mind. You see, when I do the workshop, you can see I'm just showing you the structure, that's all, because it needs a lot of time to understand. You see, it's not just easy to produce this. You must really understand. But this is called measurement model. This is what we are doing in the EFA. See, just now in say personality 1, personality, we had about 10 items, and then we split them into 2 factors, and I call that personality 1. All that can be done here, you know. All that can be done here under the factor analysis mode. But whatever you do, you are doing out here. That's why it's outer model. This is called outer model. Everything, this is a construct. Construct and the item is outer model. Construct, item, outer model. Construct, outer model. Outer model, outer model. But inside here, when you connect the blue circles, that is called structural model. That's the structural model or inner model. So this is where we look for the relationship. This is where we look for the predictors. This is where we look whether it's a model or not. It's the accepted model or not. So model fit and all that. We will check here. See, I was just simply exploring. Actually, I'm exploring. You see, this is personality 1. Actually, I put all the arrows wrongly because my main concern was personality to the pedagogy. So by right, the arrows should come from here, you know, to everything else. Okay. I made a mistake by putting no self and creating. But if you don't like anything, let's see if this is wrong, just double click and then you remove it. Double click, remove it. You see, you can do a lot of things just on the figure. See, you know why I'm disconnecting? Because the connection should come from, sorry, okay, connection should come from the other pillar, the personality. Sorry, what is that? Should come from here. This is okay. To the pedagogy is okay. To the pedagogy is okay. But this is the main filler. So you connect this way. And then connect this way. That's the main filler. Personality is the main filler. And then connect here. Connect here. You see sometimes, you see the line is running across. So what you do is that you can undo and then you move this blur so that you can see it better. Maybe this one is mixing, so you can push this one down. You see, you have the option, you push it down, bottom. Okay, it goes down. So you see, you can see all the parts. From here to here, then back here is a mediated part. You see, you can check whether got mediation or not. Whether personality influences pedagogy through knowledge of self. Whether personality influences pedagogy through subject knowledge, through student knowledge, and all that. You can draw a lot of things. Actually, a lot of relationship studies is called, this is actually called multivariate data analysis. So let's say I fix all that. Then I want to check the strength of the parts. I just go to calculate and then ask it to do a calculation. You see, it's calculating, start calculation. You see, it gives a report. This is a report, this is a report of the part. All the parts are here, the values. You see, all the numbers are also here. At the same time, it will also show you the numbers on the concept map. You see, all the numbers are appearing here. The same numbers are here also in the report. But we can put the numbers back into the diagram. You can read them directly. You see, the path from here to here is 0.538. Path from here to here is 0.174. Path from here is 0.233. From here to here, 0.59. Then going that side, 33. From here to here is 0.55. Right? So the bigger the number, the better it is. Actually, in the SPSS, we do the p-value. Here also you have a p-value, but you have to go to the bootstrapping, another procedure, bootstrapping, and that will tell you whether they are significant or not, the values. Bootstrapping takes a bit of time. You see all the numbers are there, and you see it shows by the color whether it's significant or not. Blue means significant, p-value, blue means significant, p-value, red means not significant, red not. In SPSS it doesn't show by color. Okay, but here you see in color, so you can see, and then you can also see that on your platform. Okay, all the numbers are here. This is a different set of numbers. These are T values. Any value more than 1.96 is significant. So this is significant, significant, not significant, significant, significant. Smaller means not significant. This is not significant. This is 1.2, not significant, must be more than 1.96. So this is, so you see how we can see the significance of the relationship, whether the significant relation exists or not. We can use this method to check. So this is another tool which I intend to do it separately with my students, all my students. All of you are my students. I have no preference for my supervisors. Supervisees are supervisees, my own students. But besides that, I'm teaching everybody. So I will run the workshop later. Of course, at least 2 workshops so that you can understand, you can perform. But the difficult part here is that to get this software. I had bought it. I bought it. I have the license to use. I bought it. You know how much I paid for that? For 1 year? 1 year, I paid about 1,100 Malaysian ringgit. I bought the software paying 1,100 Malaysian ringgit, and that one is only for 1 year, and that also considered half price because I'm an academician. I have to mention my name of the university. I must mention I'm part of the university. I have to show them my ID card, my SEGI card, and all that. Then only they give me the 50% discount. But students, I think you can get a free version for trial, free trial. No, but then the subjects, the sample size must be 100 only. So you can't use that for your real study, because your real study will go into 300, 400. maybe you can't do, but practice, yes, we can use the 100 and practice. Okay, so this is another very nice procedure, nice tool which can show you very clearly. Okay, so once you get used to it, it's very easy, and the way of reporting is slightly different from reporting the SPSS. Okay, here you may have to report accordingly. You have to report the relationship values, construct. You can find construct validity and all that, you know, here. See, SPSS you can find, here also you can find. You see, there are a lot of things here, path coefficient, see, a lot of things. These are path coefficients. I mean, follow each line. See, that line was significant or not. This line was significant. See, red means not significant, because naturally, if the value is 0.05 and below, it's significant. More than that, it's not significant. So here, what helps us is that besides the number, the color also tells you. So if you see a green color, is green, good to go. Then red color means no, it's not good. So from here, after seeing that, I'm just using another 10 minutes for that, just to introduce something like that. Let's say I see a rate here, and I want to see this rate from where to where. It's from student pedagogy. So I remember, student pedagogy is not significant. So what I can do, I can go back to the model and remove that line, because it's not significant. Okay, then I see this one, subject knowledge also not significant. So I can remove that, subject knowledge to pedagogy. What else is there? Personality 2 to pedagogy, not significant. So student knowledge, subject knowledge, personality 2. So all these 3 lines are not significant. Meaning that student knowledge, where is it? Student knowledge here, student knowledge to this one. It's so small, isn't it? That's why it's not significant. So what do? You go and double click the arrow, take it off. Don't connect them anymore. Subject knowledge to this one also. The moment I tamper, I do something, all the numbers will go off, because it's a different model. Each picture, each line, they belong to one model. So the moment you touch any one of the lines, you remove or you connect a new line, it's considered a new model. So a new model needs new calculation. So automatically all the numbers, all the figures, all gone already. No more report. All the report gone. Okay, because I removed this. Then this one also I thought context is good. What was else? Personality 2. This personality 2, that one also not good. And then what else? Was it subject? What else? Student knowledge taken. Subject knowledge is, I think, not good. So take off. So now my model is like that. So there's only one mediation. That is personality 1, 2, no, self-knowledge, and then to here. But there's one more also, from here to context and back here. So you can run the show again, algorithm, let it run and produce new numbers. Okay, so all the values are there. See, all the values are there. And this is the construct validity. You see here, construct validity. What we are doing there, reliability index, isn't it? Reliability index, that's also construct validity. So look at the numbers. Contacts for the measurement model context, that means the items that contribute towards context knowledge, they are good items. They are giving 0.9330 reliability index. Knowing the self is giving me 913, 944. So this is reliability, no? It's a reliability test. And you can use Cronbach alpha. You see Cronbach alpha also. Or the latest measure is row A. This is the latest measure for reliability. See, all green means they are good. See, besides telling you the figure, it also gives you one shot whether okay or not with the color. Red means you be cautioned. Sometimes red doesn't mean you're wrong. It's just that your value is a bit weak. Okay, it doesn't fulfill the basic criteria. This is all more than. You see, all of them more than 0.9. So they're good already. You see, good. Okay. This data I'm using is almost similar to what we are using, in the SPSS. You see, can you see there the context knowledge, knowledge of self, pedagogy, personality 1, personality 2. Actually, I took from there and I just tried yesterday. I was just trying it out here. If there is time, I wanted to show you. Lucky we had some time, so showing you. You see how fast I can do all this one shot. You see, I wanted to see the whole thing. I can see here. These are actually path coefficient or the regression coefficient. The higher the number, the better is the path. See, compared to between these two, this is a better path. Okay. See here, when you're looking at a mediation like that, personality 1 has got 2 parts. One is called direct path to pedagogy. Another is called indirect path to here and then to here. So when you compare the 2 values here, this is smaller than this. That means this indirect path is stronger than the direct path. But whether both the paths are significant or not, I have to go and do a bootstrapping. I do a bootstrapping. I will explain what is bootstrapping in my workshop. Okay, now again you see the p-values. All the paths that I have drawn in the map, in the concept, all are significant. All are significant. The direct path, if I want to check the specific path, this is a specific one. Personality 1, content, and then to, personality, context, pedagogy. The other one is personality, know self. That means both the mediated paths are significant. What do I mean? Mediated path, this one. From here, coming here, going there, significant. From here, coming here, going there, significant. The direct is also significant. Okay, I believe direct also significant. No? Look at the specific parts, look at the total indirect part. It's the total indirect part. No? All significant. And path coefficients, all are significant. That means it's a good model. See, this is a good model, but you can check the model also. Just see. Where is your model check? There is one value called SRMR to check on the model. No? And just now I showed you the measurement model. No? You see, measurement model. I told you this is a measurement model. One construct with its items, another construct, items, another construct, items, construct, items, construct, items, construct, items. All these are called measurement model and sometimes called outer model. They are staying outside. But inside here we call inner model or structural model. That's how the word came, structural equation modeling. Because the inner one is called structure. That means it's a relationship, it's a connection between constructs. Okay, construct, all this. But outside here is a construct and its items, the indicators, the items, sometimes called manifest variables. This is a latent variable construct. This is called manifest variable. That means they will decide on this. They decide on this. They decide. Okay. So whether they are significant or not, I've even done that using my whether it's significant or not, I've done already bootstrapping, and I know all the p-values are good, all are green. So all my parts that I drew just now, all the parts, P-A-T-H is not P-A-R-T, part. I'm talking to you parts, P-A-T-H. That means the root, all the roots are significant roots. That's how I got my green for everything here. You see, all these are parts. It could be a direct part, it could be an indirect part. I'm not sure. When you go in here, you can see. Okay, you go in here, you can see with the parts, but all of them are. Let's see any not green or not. You see, all of them are green. All of them are green. That means all the parts that I have drawn are green. Okay. Okay, that much for smart. Yeah. Can I call it smart? Can we call this tool smart?
Yes.
Yes.
Yeah, sure. We can call it smart because it's handling so many things at one go. You know, it really helps you. But to know that, you need to practice. That's why I said one workshop is not enough, at least 2 workshops. And that also must come just before you want to do your analysis. You have got your analysis data, you are waiting to do your analysis. I come in, I teach you, that will be wonderful. Okay, yeah? Don't worry, I'll be here until you finish. Don't worry. I think most of you can finish while I'm here. I won't leave any sooner. I have to produce my supervisees as graduates. So until then, I'll be around here so we can see again. If not, I may also run a workshop much sooner. Okay, maybe. But basically, I know that if I teach you something that you don't use now, it's not good. It won't help you because it's only a knowledge. You don't get the skills. Only skills that you practice will come to you and stick with you. They will stick with you as your acquired skills. You just see me do, you know how to do, you may know how to do, but you didn't do because you don't have the software. The software is very costly. Okay. So, and one more caution, if you think that, oh, I want to download my Smart PLS, the free version, they only give you once. So if you go in now, tomorrow itself, you go in, you say, I want to experience, yeah, go in, they'll give you 1 month. After that 1 month, you cannot ask for a second 1 month or free trial. No more already. No matter how long later you go in also, they can detect. Because when they give you, they will identify your computer number, ID number and all that. So they won't give you back your name, your email and all that. They have some way of tracking you. So they won't give you another time. So you have to purchase. So when you buy, you must use your university identity where you are working, and then your identity as a lecturer or tutor or whatever, then they will give you the 50% discount. Okay? If not 50%, the whole thing I should have paid $2,200. Okay? It's a professional version. That means I can use as many numbers as possible, as many sample size as possible. I'm given everything there in the license. See, they don't restrict me from doing that, doing nothing, no restriction. I can use it as how a professional will use. Of course, reduced price, half price. Okay, okay, that's a good thing for you, at least now. Okay, if you think that later your analysis is going to be using Smart PLS, you can ask me, you can communicate with me. Okay, okay, now we break here. I will come soon. I don't have a tutorial for you. If you want, you just practice whatever we were doing it. And then at 2 o'clock, I will communicate it because I need to finish everything today. So at 2 o'clock, I will come in with my regression techniques. All sorts of regression techniques we will do, after which I will show you some examples of real studies and the real data analysis that they intend to do. I won't show you the analysis, but I will tell you what are the techniques that they are going to do. And I'm sure by that time, you know how to do also, because you have learned. You know how to do EFA, you know how to do reliability. What more you are waiting is regression analysis. So once we have done that, you can do everything. You can do a t-test, you can do ANOVA, you can do a regression, you can do an EFA, you can do a reliability, everything you can do. Testing for normality, everything you know. All that is needed for your research is provided. Okay, I see you at 2 o'clock. Thank you, class.
Bye.
Bye.
Thank you.
Thank you. Bye.